No matter the type of game you're making, you're going to need some user interface. Whether it just be a couple of texts overlaying giving you a score, or maybe your entire game is played through a user interface. So today, let's get started with the basic concept of how to set up UI in Unreal Engine using widget blueprints. A couple of the most important do's and don'ts, and general information that will be useful going forward in the rest of this series, where I will be taking a deeper look at individual widget components to really start dynamically building out your UI. But today, I just want everybody to be on the same page, making a piece of UI and just adding it to the screen and making it look a certain way. So first and foremost, we're going to get started here by going in and going to user interface after we right click, and then we make a widget blueprint. Pretty much everything we're going to do, we're going to make off of the widget blueprint. There's a bunch of classes here that you can make this off of. Again, most of the time what we're going to do is we're going to just make it off of the user widget. The widgets themselves kind of work in the same way as any actor or object would, meaning that you can make children of the widgets that you've already created. So you can set up a parent widget with a bunch of code on it and then override that code, or otherwise just use that code to set up certain things, like making a color a variable. You can then make a bunch of different children off of that and just set that variable to something else and it will look different. Anyway, for now, we're going to just call this something like BP or WBP for widget blueprint. Some people just do W for widget. I like WBP. And we'll just call this the HUD or something like this. This is going to be the thing that we actually add to the screen. There is an important distinction to be made with widgets, and that is widgets that you add to the screen and widgets that you add to other widgets. And that distinction more or less mostly comes down to what you're going to use to house these widgets, because these widgets need to exist within some sort of space. We can just add in a button like this if we wanted to, but now the button is the entire screen, which is not what we want. So we need to give it some space to live in, like giving it a house, right? So there's a couple of different things that you can do. You can give it a border, or we also have this thing called an overlay, which is just an empty space for a widget to exist in. If you're going to be adding a widget directly to the screen, usually that means you use a canvas panel. And the reason we use a canvas panel for things that we add to the screen is because it has very good intelligent scaling to scale across multiple different aspect ratios, different resolutions, and that kind of stuff. That also means that they're more expensive to render. So you don't want every other sub-widget that we're going to be making throughout the rest of this series to run off of a canvas panel. So any widgets that you make that you're going to be adding into this won't use a canvas panel. Those will use something more along the lines of the overlay. And I'll just actually show you. We'll make a new widget here and we'll call that sub-widget, WBP sub-widget. And that one, I will add in an overlay. And at first glance, these will seem fairly similar, right? If I go back and forth and I select this one as well, like this looks effectively the same, just slightly different zoom levels. See, it's effectively the same thing. But what if I add in an image to this overlay? The way we can do that is just typing an image. It's a pre-existing widget component that we can use. And you can either just drag it in like this, or more importantly, you can drag it into the hierarchy to have a little bit more control over what you attach this to. Because if you have like a bunch of different things already set up here, you want to be sure that you attach it to the right thing. But as you can see here, this image now is just kind of like a small little image here in the top left corner. And there's not that much that we can do about that. We can align it with this menu on the right side to something else. We can align it to the middle. We can align it to the left or the right or the bottom. Or we can make it fill the entire thing horizontally and or vertically. So that's what these things do here for the overlay slots. But we can't very easily say, I want it to like exist over here. If we want to do that, we need to set up a whole bunch of like extra stuff and weird stuff. And then it's also going to not very intelligently scale if we add this to the screen. Comparing that to adding in an image into our canvas panel over here, you'll see that it adds it in somewhat the same way, but when I click on it, I first and foremost have this little anchor thing. We'll get back to that in a moment. But now I can just place this wherever I want on the screen, just like it is a program like GIMP or Photoshop. I can very easily make it whatever size that I want it to be, and everything will be good. Now, we have these anchors instead of with the overlay where we had these alignments only. Here we have a position and a size for the anchor for this image. And that is going to give us information about where on the screen to anchor this to if we stretch this screen out, right? If this screen suddenly becomes twice as wide, what do we want to do with this image? Do we want it to like stick close to the center of the screen, at which point we'll just put this anchor to the center and it will scale proportionate to that as its pivot point. If you've ever done any like 3D art, you know the pivot point of your mesh. These anchors are kind of like that. And we can actually kind of test this out with here on the top right side. We have a couple of options for the screen size that we want to test this out on. So if I want to go onto a phone, so a bunch of presets here. I can say, well, actually, I want to see what this looks like on an iPhone 10, right? And then suddenly this is the landscape mode, clearly. And we have a couple of things for like safe zones, like don't put anything important into these red areas, because this is going to be where your like top notch is, I believe. And this bottom thing, I am not entirely sure what it is. It might be the like side of the screen or whatever. I don't really know much about iPhone stuff. But we can see this like tablets, iPad Air 2, right? Suddenly has a different aspect ratio as well. So we can see how responsive our UI is on different screen sizes. And there's a whole bunch of different presets here. Now we also have this fill screen or custom on screen, desired and desired on screen. For canvas panels, that's generally not as important. But if you go back into this widget over here, that might be a lot more relevant, because now it's set to filling screen. And you can see that the overlay here fills the entire like 16:9 screen. But if I set this just to be desired, this is one that you're going to be using a lot, desired, you see that it actually, the overlay scales just to its contents. And we can test that, because if we put this WBP sub-widgets into our HUD, which we can just do, the moment we make a widget, it becomes available to put inside of other widgets. So WBP sub-widget, right? You can see that indeed doesn't fill the entire screen, but rather it like spawns in about this size. And now we can actually start seeing as well that indeed this thing, the image that we put in here, just aligns to the center. It doesn't grow when we make this entire area bigger or whatever. But if we set this image up to instead fill the horizontal and vertical space, you can see that now it does do that. And of course we can do this in whatever way we want. Maybe I want this to align to the right and fill vertically. So now it will do that. It will fill vertically and align itself horizontally just to the right. When making sub-widgets, usually the first thing that I do is I come up here and set it to desired or desired on screen. It's effectively the same thing. Just so that you have a better look at what things actually will look like when you put them into your canvas widgets. Now, each individual widget is also going to have its own unique stuff, mostly to do with its appearance. So if we put in an image here, we can set its brush to either an image. We can give it a tint, which is just going to be a color. If we put in an image in here, it's going to tint that image to that color. So let's just put in like a temporary image that we can, like this. You can see that it's the material for the mannequin is now tinted a little bit blue, because this just applies a tint to the input image, which is actually really, really kind of useful. But we're going to keep this being white, which is no tint applying at all. For images specifically, we can draw it just as an image, but we can also draw it as a box, which gives us a little bit of margin to put on any of the sides. So that just kind of stretches the image out. We can draw it as a border, which for an image is a little bit weird, but this is how we kind of like render a border. So these numbers now represent how thick the border is on any given side. If you just want it all to be the same side, you can just not do the individual values. You can just put one value in here, like 0.3 for instance. and everything will be set to 0.3, which is clearly a bit too much. So let's do 0.1, maybe even like 0.05, and that will now be a border. Then we have, of course, got the image, which is just normally rendering it as an image. And we also have a rounded box, which is effectively just an image with outline and rounding settings as well. I'm not going to go over every single appearance option and every single widget. Most of them are fairly self-explanatory. Like if we put in a text, it's going to have a thing for its fonts, which include fonts specifically might be something that we take a look at in the video where I want to talk a little bit more about text because they are a little counterintuitive. But that also includes like its font size, right? The letter spacing, the skew amount for letters, all that kind of stuff. Most of this should be fairly self-explanatory, I imagine. So now that we have this, let's just put this at the bottom right, and then this will be aligned to the center. So we'll put it right there somewhere, right here maybe. And then this will be aligned to the top right, but we're going to put it in the top left, or the other way around. It's going to be aligned to the top left. We're going to put it in the top right. So now we have a widget that's going to be a bit of a mess. And that is on purpose, because I want to show you what this anchoring actually does. And for that, we need to add it to the screen. So let's do that. I'll go into my third-person blueprint here. And I'll add a begin play. My blueprint has been kind of messed up lately, so I need to... And I will add a begin play event, in which we can create a widget. And this is just like spawning in an actor or constructing any other type of object, but it's specifically made for creating widgets. So it only shows you widgets to be created. So we'll create a WBP HUD. You can give it an owning player in case that is relevant for what you want to do. This refers to a player controller, not a player character. So if I just want to like get a reference to self for this, right? That isn't possible. We need to get player controller instead. And then the return value will be the instantiated widget object, which automatically is actually going to return a object of the exact type that you're making your widget of anyway. So that's kind of nice. You don't need to like manually cast it or anything. And when we have that, we can just add it to the viewport. So add to viewport. In newer versions of Unreal, we also have this add to player screen, which is really nice because now you can add widgets to specific screens if you're doing like a split screen game. I haven't personally explored that too much, but that is a thing that you can do apparently. Usually we just add to viewports. If you don't do this, the widget will be created, but it just won't be visible. And there's an important thing with widgets, and that is that we don't manually like destroy them or anything. Widgets rely on Unreal's built-in garbage collection system, which means that they only get destroyed when there is no more references to them existing anywhere. So as long as I like promote this to a variable as well, right? So we can like promote to variable. I can then remove this from the viewport and the object will still exist and I can add it back in at a later date. If I don't set this to being a reference variable, first and foremost, I won't have the capability of removing this from the screen at all, aside from maybe doing it from the widget itself. But then when it does get removed from the screen, it no longer has any references anywhere, so the object will actually get destroyed because Unreal doesn't hang on to objects that you are no longer able to use anyway. Which usually is a good thing because it takes a whole lot of like memory management headache out of your hands. It can also be a little bit annoying because if you want to destroy a widget, the only way to actually destroy it is to make sure that no other actors or objects have any references to it left over. Which in some cases can be a little bit of a headache. So let's give this a good name, HUD widgets. Anyway, with that, we will be able to see that if I now play the game, it adds my image, but you don't see the other two things, and that's because they are not properly aligned. If I tab out of this and I make this wider, you will see that it starts showing up with the text block and that image. And the issue is that these two things are aligned to this corner, which makes them really confused as to where they need to exist on screen. You can see that whatever I do, this thing kind of more or less stays in the proper position because it's aligned to the center of the screen, meaning that when the screen grows to the right, the image goes a little bit to the right, and to the left, it goes to the left. when the screen gets really thin, it starts going up a little because it tries to maintain its relative position to its anchor. But of course, this thing thinks it's anchored all the way to this corner over here, and so does this. So if we now go back in for our HUD widget, and we actually set these anchors to being in places that make sense. Anchors have a couple of presets, by the way, where they can be aligned to any of these corners or the center. We'll get into making these type of anchors as well, because these are more than just points, right? You can do wacky stuff with them. For the most part, right now we're just going to do these as points. I'll show you a little bit what the difference is in a moment. Now that we've done that, you see everything does end up being properly on screen. And if I use F8 to tab out of the game again, everything stays more or less properly on screen because it has the proper context of what it should be aligned to. So setting up your anchors properly is quite important. Now, anchors also, as you just saw, have this capability of having like these 4 corner pins. And generally speaking, what you actually want to do is not just align things to a point. Well, most of the time that is good enough, and sometimes it is preferable. But oftentimes what you'll actually want to do is you want to align these corners to the actual corners of your widgets. This is just kind of a more in-depth version of anchoring, because now the anchor is actually aware of where the corners of your image exist and can scale things a little bit better accordingly. So for this one, I could just anchor it out to this, but I could also say, well, actually the image only exists up to here, right? So let's put the anchors in a way that it just covers the image, not the entire widget. And for the text block, I can say, well, I can just make it as big as the text block, or just as big as the text, or maybe a little bit bigger than the text. You really get into very situational stuff on what you want in any given case, but for the most part, just aligning these corners to the corners of your widgets will give you the best results. And now you can see that it does things even a little bit better, at least for these two. You will notice that this one does start getting squashed down a little bit. So again, sometimes maybe you don't want to do that. Maybe sometimes it's not preferable to use corners because it starts like squashing down images like this. So for this, and this one technically too actually, because you can see that it does become thinner as we go along, these are images, so we don't want those to like squash and stretch. But the text, for instance, we do want to maybe scale with the actual side of the screen. You can see that as the screen becomes smaller, the text will also become smaller and then bigger again. So for the text, that might make sense. For these, that might not make sense. So for these, maybe what we want to do is we want to just align these to like the center position of where it exists on the screen. Same thing with this. Aligning it to a corner or aligning it to the center. For this one, I think aligning it to the corner of this specific image makes a lot of sense. And you'll see that it stops being squashed and stretched now, because it doesn't have that height and width information, so it's not going to squash and stretch it as a result. So there isn't a one-size-fits-all solution for what to do with these anchors, and they often end up being a confusing thing people get hung up on. For the most part, the very most important thing is that you do give them an anchor position. And if you want to play around a little bit with giving them those like little corner positions as well, you can do that. If that does end up messing with your scaling, if you scale up and down your viewport size, you just go back to either setting up different corners or just singular points. So now as a last quick thing, what I said about these sub-widgets is that we can set these up to have some code of their own, and then we can either make children of them or instances of them and set their values to something different. I'm going to do something super quick with this image over here. What I'm actually going to do is I'm going to make this into a couple of different images. That's the reason that I use an overlay here, because if I just wanted this to be one image, I could just set it to being an image. But an overlay is a space that allows multiple different sub-widgets. Not every type of widget allows any sub-widgets or even multiple sub-widgets. If I try to make this image a child of this image, it can't do that because images don't support having child widgets. We'll get around to setting up stuff about that in a later video, but for now I'll just make 4 images. I'm going to align these to the corresponding 4 corners. And what we're going to do is make this fill screen real quick so that I can see which corners I have already done and which ones I have not. I am missing one of them, which is here. No. Okay, now we've got these in all 4 corners. For the draw size of these images, I can actually set them to draw as bigger images as well. So I'm going to set this to draw as images that are 100 by 100. You can very much just select multiple of these at the same time and just update their values. So now I've got 4 images that will display as 100 by 100 units. So if I go back into the HUD, you can see that that is very much what this does now. Every single widget comes with its own event graph as well, which you might have seen already. So we can set up these images, all of them, to work off of variables. And here we have 3 different events. Event pre-construct, event construct, and event tick. In a lot of cases, pre-construct and construct will do the same thing for things that are dynamically added, like during runtime. So event construct usually is good enough. The big difference is pre-construct also works in design time, meaning that it will actually run the code whenever you put it as a sub-widget into another widget. So I'll show you that. We can set this brush from a texture, and I will just copy that node over a couple of times and hook up the other 3 images to that as well. Texture, and that one, and then that one. And then I will promote all of these to variables. So there'll be texture, texture 0, texture 1, and texture 2. And then if I set these to be instance editable, like exposing them, going back into my HUD, I suddenly have these 4 textures to fill in. So I can set this to a texture, and you can see that it fills it in. It is a little bit weird with the normal map, so maybe use something that's not in normal map. So now that's this one thing. And you can see it does it in the designer. But if this were in the normal event construct instead, you would see that it doesn't actually do it in the designer here. But if I actually run the game, you will see that it still does do it. Because event construct only runs in the actual game. Event pre-construct also runs in your widget editor. That's why it has this in design time value. Because if you want to do something that only shows in previews, you can just add in like a branch here for design time and then do one thing if you're in design time. But if this is false, you do something else because that means that you're just like on runtime, right? So that's the way that you can set up these like sub widgets that can get instanced over and over and over again in a bunch of different places. Now, there's a couple of other events that you can also take a look at. Like on destruct, which is just when it gets destroyed. Again, this is a little bit weird because it gets automatically destroyed by Unreal's garbage collection when there's no longer any references that happen to it. But that doesn't necessarily happen immediately because Unreal's garbage collection works on just like every now and then it runs, right? It doesn't run every frame or anything. And then we have a bunch of other things that aren't necessarily super important to do right now. Aside from one that I can't see in here right now, which is called onInitialized. There's an important distinction between onConstruct and onInitialized because onConstruct runs every time you add this thing to the viewport. OnInitialized, however, only runs when it is initially created. So if we go back into here, when we run this, it will run onInitialized. When we do this, it will run onConstruct. So if you want to run code before adding something to the viewport, you run it on initialization, not on construct. For all practical purposes, that does seem very similar, and in most cases it will be. But sometimes you want to pre-create a widget and run some code on it, and then be able to just add it to the screen at a later date. At which point the information that you might want to pass into it might have already like disappeared, or it might be different or whatever. On initialized, there's a reason that it doesn't give you one of these ghost nodes by default. It's not super often that you can, but it is good to know about it. That is a basic overview of the most important things about creating widgets in Unreal Engine. This is a bit of a mess of a video compared to the other videos in this series because I just want to show everything that is most important to understand. So as a recap, we have canvas panels, which are expensive to render, so you don't want to use them all too much. Only use those for widgets that you physically actually add to the screen for your player. then any sub-widgets that we want to make those, for the time being, we're just going to call those overlay widgets. Those are widgets that we make with something other than a canvas panel. In this example, we're using overlay. We're going to be using overlays a lot, but there's other options to use here. Overlays might initially seem more restrictive because you can't easily put images in places that you want to put them, unlike the more freedom that we have in a canvas panel. That's something that you're going to get used to. It's not going to be that big a deal once you're actually used to it, and these do perform a lot better and also more predictably. And on the canvas panels, do make sure to anchor things to positions on the screen that makes some semblance of sense. Well, next time we're going to start diving into this whole palette on the left hand side here that we have. There's so much stuff to take a look into, and all of these have their own little like neat tricks and things that you need to know about them. Some of these I will combine into videos, like when I talk about text, we're going to be talking about text and rich text in one video. But by the end of this series, I'm going to have talked about most of the things in this menu. So there's going to be a lot of it. So we already talked about the concept of having canvas widgets and then having sub widgets as well, right? These are widgets that we add to other widgets. This is a widget that we add directly to the screen. If you have missed that, the introductory part of this series goes over all the most important stuff you need to know about that. But now, I want to talk a little bit more about different types of sub-widgets that we can make, because I just did one here with an overlay as an example, and that oftentimes will be the more used type of sub-widget that you can make. But it's by far not the only one, and we're going to be talking about a few more later down the line, but I want to talk about some of the more useful ones that we're going to be also using in a bunch of other different examples moving forward. So let's go back to our HUD to talk about the different types of these boxes that we have, and then we'll maybe make some actual sub-widgets out of those in a moment as well. The thing that we're going to be talking about will be the horizontal box, which is a box that sorts things horizontally. The vertical box, which I'm sure that you can imagine what the difference between the two of these is. And then we also have the wrap box, which is a little bit less intuitive, but also really, really powerful. So let's add in all three of these to the screen. Now for these, I'm going to set their anchors to actually align with how big they are on screen, because they, as the boxes themselves, will get squished and stretched, but the content inside them doesn't necessarily do the same. Specifically for the wrap box, that is a relevant thing to keep in mind. So I'm just going to align all of these kind of to the corners of their screen positions. And then let's start adding just buttons. We'll talk about buttons a little bit later because that's making your stuff interactable. It's really, really nice. Really, really important, of course. If I just add in a button to this horizontal box, it adds it to the left. Okay, cool. Let's click on the button and see what we have as far as alignment goes. You can see that the alignment is more or less the same as we had when it was part of a overlay over here. We can align this to the left to the right, but if we align it to the right, it's still sticking to the left. And that's because the horizontal box is the thing that's going to keep things, well, horizontal, right? So it's always going to add in multiple buttons side by side like this, going from left to right. So that's why even when we set this to align to the right, it still sticks to the left, because it is aligned to the right of its own slot within this box. Now we can set the size here to fill, and that starts telling a slightly different story, because now this entire thing is filling up the space of this horizontal box, and it now has more room to it than just its own size. So now it will actually go in between all the different places. If we set both of these to being fill and aligning to certain positions, you can see that even if I now align this back to the right, it doesn't go all the way to the right, because both of these now have half the size of this horizontal box to them. So when I align this to the right, it's going to snap to the right of its individual slot, which is half of the entire box size. If I add in yet another button to this, and I set that one also to being filled. Now each one of these gets a third of the entire box. And you can see how this very easily and dynamically lets you add things side by side. So for instance, I will make like a fancy button with some text and maybe an image to it in a moment as a sub-widget to show you how a horizontal box works. Now, then it follows that the vertical box kind of does the same thing, just from the top to the bottom. So let's add in 3 buttons to this vertical box as well. I'm going to set all of these to being fill. And then we're going to align these to the center and make them fill their entire horizontal position. And you'll note if I increase the size of this, they all just remain with getting 1/3 of the total size of this thing and aligning themselves to the center of that bit. It's because of how we have this alignment set up. If I set this one to the top and this one to the bottom, you'll see that their behavior will do, well, exactly what we tell it to do. They still all have 1/3. This one's always going to stick to the bottom. This one's always going to stick to the top. And this one's always going to stick to the middle of the entire thing. But we can, again, just say, well, actually, I want this to stick to the top of its own segment. And then it will do that instead. So these boxes are really, really powerful to do things like making lists. We have a specific list view. If you have a bunch of items that all need to display the same thing. But a vertical box, our horizontal box, is a really nice, more simplified way to make things like lists. And the actually wonderful part about horizontal and vertical boxes, compared to lists, which again we're going to be talking about in the future, is that you can add in multiple different types of widgets. So right now we're just doing a bunch of buttons to show things off, but if I want to add in like a text, I can just simply add in a text to this, and now it also has a text in it. And then if I want to add in an image as well, there's nothing to stop me from doing that too. So that works quite well. Moving on to the wrap box, which I think is the next most important thing in this situation. Let's add in just a bunch of images. So we add in an image and we add in another image. It adds it next to each other. Let's actually give both of these a little bit of padding. Well, actually, let's add in a bunch more images first. So we add in one more image. I think we can just like copy paste these as well. Makes it a little bit faster to add in a bunch of them. And you can see that we're starting to add in quite a lot of images here. So if we make all of these render at 100 by 100 instead, you can already see what this wrap box is doing. When there's no more room for an image to go side by side, it just goes to the next row. If I then set the padding for all of them to like 5, you can see the difference between their location a little bit better. And if I give it enough room, it automatically adjusts all the wrapping. But if I don't have enough room, it also automatically adjusts the wrapping. So for things like making inventory screens or whatever, these wrap boxes are really quite useful. Because if you want an inventory grid that works in a bunch of different situations, displaying your inventory, even if like sometimes maybe you want to display your inventory in a 3-wide grid, maybe sometimes in a 6-wide grid or whatever. These wrap boxes kind of just take care of all that for you. You might have noticed though, one little thing, and this goes for all of these types of boxes, but specifically for wrap boxes, this ends up being super useful. If I make it too slim, it starts putting them outside of where I want it to be. So we actually don't want to do that because obviously that's a bit of a mess. That's where we can add in a thing called a scroll box. So if you put in a scroll box anywhere in here, and then you put the wrap box or vertical box or horizontal box inside of that scroll box, we now have the scroll box over here. You can see it still works as the wrap box that it should be, but we also get this little scroll wheel, which I can actually show you how that works if I align this kind of a little bit better with the screen again, when we go into play mode. So in play mode here, we can see we have all these buttons and all that kind of stuff from the horizontal and vertical box. And then because we have this wrap box in a scroll box, we can scroll up and down it. But as the screen becomes wider, it automatically adjusts the scroll box, or the wrap box rather, and allows us to scroll up and down as much as is required to get all of the content out of it. Now, of course, There's nothing to stop you from using scroll boxes with horizontal or vertical boxes either. And you can easily add them back in at a later time if you realize that, oh, actually I want this to be a scroll box, by just right-clicking anything, and you can wrap it with another widget. So in this case, I want to wrap it with a scroll box. The scroll box does kind of get rid of the spacing. It just adds in everything on top of each other, as you can see. But now if I make this thing too small, you see, we can start scrolling through it. Same thing here, horizontal box. If we just wrap it with a scroll box, which is right here, and we make it smaller, it doesn't do anything. And why doesn't it do anything? Well, that is because by default, the scroll box will scroll up to down, because that's how you 9 times out of 10 are going to scroll through things. So if you just look at the scroll box's detailed panels, we can see that orientation, we can set it to horizontal. And now, suddenly, if we make the scroll box small enough, it adds in a scroll wheel from left to right as well. There's a bunch of other settings here that I don't really want to go over because most of them are fairly self-explanatory. It's the thickness of the scroll box, whether or not it shows you the scroll bar even if there's nothing to scroll, all that kind of stuff. You can probably figure most of that out for yourself. If you still do want to have distance between all of these buttons, of course, you can add in a little bit of padding to either the left or the right. So let's say to the right, we want to add in just like 5 units of padding, maybe even like 10 units of padding, and then probably to the left as well, so that it's equally on all sides, the same. And we can do the same for these things over here, give them just to the top and the bottom. And we start making widgets that actually kind of look like usable UI in a way, aside from the fact that this is super thin at the moment. So you can imagine how this ends up being super useful, because if we go in and we make a like WBP, I'll call it special button or something like that. So special button. I can make this a horizontal box. We'll set this to being desired, as I showed you in the first video of this series. And I want this button to have an image, then a button, and then a bit of text, right? So I can set this to be an image. Then I can add in a button. And then I can add in a bit of text after the button. Now, in this case, the button is actually quite small, and that's because it doesn't have any content. So you can add in some content to the button. So another text here, for instance, to make the button a little bit bigger. You can also use other types of widgets to force it to be a certain size. Again, something we'll talk about a little bit more in the future. But now we have all of this more or less set up, right? So we can keep this aligned to the center. Maybe make the font size for this a little bit smaller. And now we have our little button that we can set up with our variables if we want to, right? So we can make both of these text blocks into variable. This image by default will already be variable. So now on event construct or pre-construct even, we can set the text box text for both of these, and we can set the image for this. So we set brush from texture. Just promote that to a variable, expose it, and then maybe give these two a better name as well. So this will be the button text, and this will be the end text. Badly named, I know. We just set text on this. You have a direct set text variable or a function. They do essentially the same thing. It's just generally better habit to get into using functions to set variables instead of variables directly, because you never know if a function might do more than just setting the variable, maybe also like broadcasting a event dispatcher or whatever. And if you're doing your own code, it's also good to get into the habit of making functions to set variables, because then you can easily add on new code that needs to happen always when you set that variable. Either way, we can set both of these texts. Obviously all need to be variables as well. And let's say in this vertical box, let's get rid of these things that we just did now, and we'll add in these special buttons instead. You can see that these special buttons, we can set our texture. We also need to set the variables for these to being exposed, otherwise they're not going to show up. So we can say, well, actually I want this image to be this, and then this is button 1 with option 1. And then I just copy this over and add in like a bunch more of these, and I can start like doing button 2, option 2, and so on and so forth. I think this video is long enough as is, so I think in the next video we're going to focus on dynamically adding things to this instead. Because it's nice to be able to do this all manually in the designer, but the thing where specifically these horizontal and vertical boxes come in really handy is just being able to supply in dynamically added new widgets, and the boxes themselves being able to just like put them into like the list. Same with this wrap box, right? If I wanted to add in like 10 more of these images, it just dynamically adds them onto the end of whatever this wrap box is wrapping. However, I think that this video is long enough as is, so we're going to leave it here. Remember, horizontal boxes, vertical boxes, and wrap boxes, they can be really useful to start building out these like combined sub widgets that you then can start building your actual UI out of at some point down the line. We understand the horizontal and vertical boxes now. We can add in our special buttons that we made with their own horizontal box into a vertical box, and we're happy. But what if we don't know how many buttons one of these things should have? What if we want that dynamically to be decided either on design time per instance, or even on runtime, adding in more to them? Well, that's actually a thing that we can fairly easily do with a little bit of work. So what I'm going to do is I'm going to make a new sub widget for this. So user interface, widget blueprint, and we'll call this the WBP dynamic vertical box. Gonna add some stuff into this. Well, first, of course, we're going to add in a vertical box because that makes sense. And we're going to make sure that that is a variable. And we're not actually going to add in anything else because everything else that we're going to be adding in, we're going to be doing dynamically. So let's add in pre-construct a for loop. This is going to loop from a value of 1 to whatever amount of things we want to have. So promote this to a variable, and this will be the amount of widgets that we want to have in this. And for each one of those, we're going to construct a widget. So create widgets. You can just hard code this to be our like special box thing that we made. But what I'm actually going to do is I'm also going to promote this to a variable. You can have an array of classes instead. That way you can spawn in different widgets in the same box. So let's just call this the user class for now. And this is going to spawn in a certain amount of the same widgets. We create that user widgets and then we just add that to our vertical box. So add child. This one right over here. That's the content we're going to be adding. And for like all the padding settings, we're just going to leave that alone for now. This is all that we need to do. Almost. There's going to be one small issue here, and that is if we add this into our HUD, let's just remove this for right now, and we add in our dynamic vertical box. If I say I want to add in our, what did I call it, like special button, and I want to add in 5 of those, it adds in 5 of them. That's fantastic. But let's see what happens when I change anything about this. Let's say I want to add in 3. Ooh, it adds in just 3 more. 7. Ooh, now I have a lot of them. Let's recompile. Okay, now it has 7 again. Good. Fantastic. Right? So that's not ideal. So if we now start the game, I set this up to like blink in and out of existence. Every time it runs construct, it's going to be adding 7 more instead of just adding 7. So not ideal. What you can do instead is in our dynamic vertical box, at the start here, just very simply get our vertical box and clear children. That way it will just regenerate new widgets every single time. Now, if these are widgets that you want to manually set values into and that kind of stuff, obviously that's not going to work so well because it's going to be clearing and resetting them. This is mostly really useful for things that are getting like generated on the fly on runtime during gameplay. At which point regenerating the same widgets again, as long as you just give in the same data, really doesn't matter that much. You don't want to be doing it like every frame a bunch of times, obviously, because you are creating a bunch of objects and then discarding them again. But for the most part, just giving in the same data makes it a pretty seamless user experience. So now that we've done that, we can see if I now change this to 3, it only has 3 because it first clears the entire box out of everything that existed in it and then adds in the amount that I type in here, entirely new ones. And just to show you that it actually kind of doesn't even seem like things are getting deleted, what we can do is we can just set this to be our special box hard-coded for now. So the special button, let's get rid of this class reference. And what that will allow us to do is in our special box button thing, we have these 3 values that we created, right? If we set this to also be exposed on spawn, our blueprint will do something really quite nice for us and give those in as input values. Set these always to be many, but the text will be the index of the array. And then the second text will always be button. So now we see it's 1, 2, 3, 4, 5, 6, 7, 8, 9. But when I set this amount to 4, it doesn't seem like these 4 got cleared. It just seems like we now just have them up to 4 or up to 12 or up to just 2, right? So if you just give in the same data to the start of whatever array that we're doing this with, it's going to be a seamless user experience. But we can't manually edit these. So that's a kind of downside to this if you're doing this for like your design purposes. This is really something that you want to do dynamically on runtime. So in our dynamic vertical box, we can also make a new custom event, and we'll call that add button to box. And what we'll do there is effectively just kind of do the same thing. We create a special button and we add it to our vertical box. And we're going to be doing this and give in like a text with it. So now what we can do is we can actually just use this add button to box event in the loop as well. But now we can explicitly call it as well, which is kind of nice. And if we want this to automatically populate instead of it actually being a input value, what I'm thinking we can do is we can get the children count and just add 1 to that and put that in as the text here. So that way it will still automatically number all of our buttons. So you can see if we just go back into here, this essentially still works the same way. So we can have 6 buttons. But now that we have that, we can also use this dynamic vertical box and we can add button to box. And we can do that on pre-construct here in a for loop as well. So for loop from like 1 to 5 or something like that, and run that function from here now. Which, that means that we're running it 6 times on the actual thing itself, and then this widget is then adding on 5 more to it, meaning that we have a total of 11 buttons. But we can go one step further with this even. So let's align this to a fun position, because we're going to be adding more of these buttons on runtime. So let's open up our third-person blueprint here, because in this we already added our HUD widget variable in the very first video of this series. And since we have that, we can get the dynamic box and we can add button to box from that. And we can just map that to a debug key somewhere. So like debug key F or whatever. And now whenever we press the F key, it's going to be adding another box to this, even if the game is already running. So we can actually show you that. As you can see, we're adding extra buttons while the game is running. So while this dynamically adding stuff is kind of limiting in the sense of doing it in the designer, because we can't individually set this stuff, anything that gets populated by data, be it from a data table or from like an array of assets or whatever, you can very easily do that this way, and that way you can dynamically change this stuff on runtime as well. And now you can start seeing that, hey, we're making responsive, interactable UI already. Now, next time I want to talk about adding in sub-widgets to your sub-widgets, because right now that is still a thing that we are kind of lacking the possibility to do. If I want to add in an image to this widget over here, for instance, I can't do any of that because none of my own made user widgets have the capability of hosting other widgets. So that's what we'll talk about next time. So we have our own sub-widgets that we're adding to our like HUD canvas here, but what if we make a sub-widget that we want to be able to add other sub-widgets to? In the very first part of this series, I showed you something like this sub-widget here, and I told you that the reason that I use an overlay here is because it can hold multiple different like other sub-widgets, in this case 4-corner images, because that was the example at the time. So you might think it's as simple as just going in and saying, hey, I want to add another image to this, and because it has an overlay, surely it's able to take in that image and add it to itself. But no, that's not quite how that works. Because from the perspective of this like canvas widget over here, this is just like a singular object now. This doesn't have any more like slots. This can't have any like children because we haven't set that up specifically to allow that. And from the perspective of this widget, this is just a singular object that manages everything about itself on its own. It's not a overlay anymore with different sub-images in it. It's just a WBP sub-widget. So what we need to do in order to fix that is we need to add in something called a named slot. So if we add in a named slot to this overlay, I'm going to align this to the center here, and I compile this. Going back into our HUD here, we suddenly can see that we have under our sub-widget WBP a named slot. And now I can just drag our image onto that named slot, and the named slot will host that image. Meaning that we can go into a different instance of this same widget class, and we can put something entirely different into it. So we can put in a text to this. So this goes one step beyond just the normal thing that we did here, which is we have 4 images, and we can actually give in the exact textures that those images need to display on like variable basis. This is now a slot that can host entirely different types of widgets inside of it. And you're not limited to only one, of course. What you can do, and it's not that difficult to do even, is we can go in, make a user interface, widget blueprint, and we'll call this a slot stack or something like that. Just make this a vertical box and add in a handful of named slots. So let's say we have this many. If we put a slot stack now into our HUD, so we can add in a slot stack here, we now have a thing that has all of these different named slots that we can put anything that we want into. Now the only major downside is following up on the last video where we made this dynamic box that dynamically adds in these buttons to this box. It doesn't seem like dynamically adding in these named slots is quite supported, because if we go into the slot stack and instead of doing this, we go into the event graph after making sure that our vertical box is variable. If I try to add a child, and we could do that by constructing an object from class. If I try to construct a named slot and add that into this as a child, that just will not work, as you can see. So it seemingly simply just does not support adding named child slots dynamically. At least as far as I've been able to figure out. So this very much is something that is limited in the way that you can apply it. That being said though, of course what you could do is you could just have this vertical box with 2 named slots in it, and you could nest these. I don't know necessarily if that is a great idea to do. I have read people running into issues with this. I haven't tried that out myself because I frankly think it's not really like all that useful, but you could try to like put a slot stack like into this slot stack, into this slot stack, and so on and so forth, right? So you could try to like nest these, and then we can add in images into these, but you can see that's already starting to be like a little bit iffy about it. Again, probably don't do this. If you're gonna do it this like weird anyway, you might be better off just designing a specific like vertical box in this one widget to do that one thing. These name slots have their limits. They are very much not intended to be used super dynamically. So just keeping it at like a set amount of name slots that you can use. You can do anything you want with these name slots. We can put in other widgets with like a lot of very complex code into those, we have like that dynamic vertical box. We can just put that into one of these name slots instead, right? So if I remove this and put this in here, it is very, very tiny, admittedly, but that is due to what we have set up here. So if I just make this like as wide as the entire thing and then as tall as the entire thing, we can set this to being an amount of 15 or something like that, right? So you can add in complex dynamic stuff into these name slots. Just they don't really seem to be happy with being nested or dynamically generated on the go. A UI without any text is kind of useless most of the time, right? You can add in images, you can add in buttons, but for the most part, at some point, you're going to want to add in text. And Unreal has 2 different text types built in. So actually, let's get rid of a bunch of the stuff that we have here from previous videos, because it's just kind of like messing things up a little bit, and just focus on the text that we already have in here. Actually, I'll just make an entirely new one, get rid of all of this code that we already had, clean start, right? So if we look for text, we have some input stuff, we'll talk about that later, but we have the normal text block, and we have the rich text block. And the rich text block doesn't come with any default text. That's the biggest difference. That's the video. No, of course not. Let's set rich text in here. You can see immediately there's already something a little wrong with this. That's not the way it's supposed to look, obviously. And that's because it doesn't have a text style yet. So for normal text, we can pretty much get like 90% of the way there, right? Because we can just type in whatever text we want to set. We can set that dynamically, obviously. We can set its color as a whole. We can set its fonts, which we'll also talk about a little bit in a moment. We can set its size, letter spacing. I showed all of you this before. Rich text goes a little bit beyond that and is closer to the way that you would see setting text in a word processor or something like HTML. Meaning that if I want a specific word to be bolded, we can make one word bolded. We can make one word a different color instead. And for that, we need to set up a text style. So the way we do that is, first and foremost, we need to have a list of text styles to begin with. So let's make a data table for that, which we can find in miscellaneous data table. And then in the data table type, we can set that to being a rich text style row. And this will be our text styles. Opening up that data table, we can add in a row. And there we get a bunch of the text style stuff. So we can set our fonts, we can set the colors, we can set the shadow, we can set the selected background. We can set a highlight color, a highlight shape, a strike brush, a underline brush, transform policy, and a overflow policy. That's everything we have here for the text style. And now that we have made this data table, we can choose our text style set and use that. Before we can do anything though, we're going to need to have a font set up here. So let's go back in here, font family. Fonts are specifically Unreal assets as well. So we can create a new font. Let's call this just font 1. And then when we open that up, we get a bunch of stuff. So we can set our default font family and a fallback font family, and we can even add sub font families. Try to say that 5 times fast. So let's add in a font here, and then we can get a font from our machine, just any font type that we have, like TFF, TTC, like TTF, TTC, OFT, all that kind of stuff that you are probably fairly familiar with. So let's actually just download a font real quick. Just real quick on Google Fonts, something that looks fun is this one. This one is very gamey, right? Bit count grid. Let's get that font. And then we can find wherever we put that. In this case, for me, that's like this file path, but wherever you downloaded it to. And we can open it up. It might have some issues with things that contain illegal characters, in which case you can just like remove those and then save that. So this is a font face, which is effectively just the asset for the font. And then this is the like font that Unreal can use, because as you can see here, we can use multiple different font families within like one composite font asset. You can even use fallback fonts. Like this goes pretty in depth. I personally don't really use this too much. because I'm not much of a graphic designer. I'm much more of the code behind everything kind of guy. But now that we have that, we can choose font 1 as our font for this text style. So now we can name this like the default or whatever. Let's copy that name over. That's the name that we're going to be using in our rich text to set this up as. So, and you might need to save and compile everything. The other text I also set over to the other font, which you can now easily do just by font family and picking that font. You can see that it uses the default text style here. But now how do we set this to using different text styles, right? What if we want to have a copied one? So let's say we duplicate this and call this red, and we change the color of this to being, well, that will be red. And we can even change it to a different font if we had a different font. I might do that in a moment. The way to do that in rich text is simply adding in these little angle brackets that we have over here, adding in the style that we want to use, typing in the text that we want to have in that style, and then we end off with another set of those angle brackets with just a slash in them. And there you can see now we have one space too many in here. So let me fix that real quick. Now we have this is our red text with our, well, red text in here. And we can set this to any other styling we want, and then that text will render as that. So maybe we want the red text to also be slightly bigger. Well, we can do that. And now if we save this and recompile this, you can see our red text also became bigger. We want it to be a different font? Sure. Let's also do it in a different font. Let's download a new font from Google Fonts. This font over here. I really like this font. It's really nice for thumbnails. Let's get this font, download it. This time I'm just going to drag and drop it into Unreal to show you that that's also a thing that we can do. A font, we can just drag and drop it in, and then it will make a font face and a font family asset right away for us. So that's an easier way to just add in a font. And for this, we now want that to be our font for that as well, which again, if we save this, compile, sometimes it takes a moment to update, but now we have our rich text block, which has two entirely different colors in one text block and two entirely different fonts. And we can set this style to change however we want, just in here. Do we want it to be more skewed? Set it to be more skewed. Sure, why not? That's the letter spacing. That's the wrong thing. That's skew amount. Let's do that instead. So now it will be more skewed. Again, you do need to recompile sometimes, and it's a little bit iffy with updating immediately, but just recompiling and saving your data table usually does do the trick. And if we keep typing after that, so that's kinda cool. It's back to the default stuff. Do we want cool to be something else as well? We can add in a new row, call this important, and maybe we make that a blue color. And we give that a different font entirely as well. And we can do whatever we want with this, right? So, and saying, well, now that's actually the font that I want to apply to being important. I think, no, that's the wrong one. It's this one. Probably don't give it any skew, but maybe we want the letter spacing for this to be like 20. It's probably still quite a lot. We can say, well, actually, I want cool to be in that important style, right? So brackets. Importantly, these names are not actually case sensitive, so I can just type important without the case sensitivity, then type in this end bracket thing here, and it'll take a moment here to figure itself out. So it might show this initially, but if we now compile this, in my case, I also just straight up did misspell important, which is kind of embarrassing, but now we have it's cool. And obviously we can set our text dynamically as well, and we can do the same thing with our rich text. So I think we did this in a previous video already. We make sure that both of these are set to is variable for now. And for text block, we can set text to whatever we want. So test text dynamic, let's say. We can even promote it to a variable if we really wanted to. And for rich text, we can do effectively the same thing. We can set the text. And we can also set the text style set dynamically. Now for both of these, we actually have a function and a direct variable setter. As I said in a previous video, it's usually better to set variables with corresponding functions, just in case the functions do more than just setting the variable. So try to get into that habit. So set text, test, text, test, stuff, text, text. Sure, that also works. And in here, we can also make this up in the exact same way. So usually the way to easily do that would be to get this to text from string. Because with strings, what we can do is we can do append. So we can do, just in the default stuff is like your score. Then we can set that up to say, well, everything here is going to be important. Then provide in a dynamic value for our important stuff. Then end of our importance with these brackets over here. And then well done. And I don't know, let's just do this on event tick actually instead. And we'll just do something like make a float for the time. And we'll just update every single frame for this. This is not the most ideal way to do this, but it's the way that I'm going to do it for now. So we do it like this, and then we simply connect it back up, and then we truncate it into an integer so that it doesn't have any decimals, and then put that in there. So we now have dynamically got our score 1, 2, 3 with a different style from the rest of that same little bit of text. So rich text, really quite cool stuff. And of course, normal text also is kind of neat, I suppose. It's there. Now, very often what you end up doing is making something like a button, which is something that we'll, again, promise talk about pretty soon. But if we make like a text button, for instance, what you'd end up doing is adding in a button. And a button can have one child. So you'd put in a text or a rich text. We're going to do a normal text here. And then you just make that a variable as well. And then you can set this on preconstruct to set text. And then you just promote this to a variable that is instance editable. Or even exposing it on spawn if you're adding this dynamically. And then if you're back in your HUD in this case, we can add in our like text button, which now gives us a field for the input text, right? So this will be our button text. And if we add in another text button, we can say like quit game on this button, for instance. So that way you don't need to add in a million different buttons, all with their own like extra text that you need to drag in every single time. You can just make like one button here with the text already like baked into it and be ready to go. And if you want to add in more extra stuff to that button aside from that, of course, you can, instead of just putting the text in directly, you can do something like wrapping this in a like vertical box and then also adding in a named slot, which we did in a previous video. And now you have a text and a slot both in this button. So now we could add in even like an image into both of these as well, if we really wanted to. So let's add in the image like there. But that's not what this video is about like at all. Just wanted to like show you that things are coming together in a way that hopefully you can understand. Either way, we've done all of our text stuff that I wanted to show you. So thanks for checking that out. And next time we'll be doing even more fun UI stuff. You've seen me adding buttons in a bunch of examples in other videos so far. Let's actually talk about buttons and making them useful. Because so far everything we've done is just been visual, but we want to be able to interact with our UI as well. And that's where buttons come in. Essentially anything that you want to interact with, there's gonna be a button behind it. So let's get rid of these three things that we have here and get started with the most basic stuff, just adding in a singular button, right? So if you just add in a singular button, we can make it as big as you want it to be. Buttons can have one child inside them. So you can add in an image into your button, or you can add in a text, or you can add in any other type of widget, really. You can't add in more than one at a time, though. If you want to have more than one thing inside of your button, you're going to need to put in a container for multiple things, like a horizontal box. If you put in a horizontal box, then you can put multiple things inside of that horizontal box, like an image and then also a text, and now your button can contain more than one thing at a time. If you put something inside of your button though, it is probably a good idea to go into its settings and look for its visibility and make sure that it is not hit testable, because you want to be able to click through it onto the button. If I click on this image now, it's not going to actually click on the button because the image itself is going to be blocking me from clicking on the button. So if I set this to non-hit testable, I think text by default will not even be non-hit testable either. So now I can click through the text and the image on the button. So how do I even deal with like this whole button situation? Well, there's two things to this. Number one is there's a bunch of styling to do with buttons, and that's because buttons have different styles for just their normal state, when you hover over them, and when you press them. So let's set this to 3 different things so that we can see that happening easily. When we hover over them, let's make it blue, and when we press them, let's make something like super different. Let's make it like a dark red. If I now go in and play my game, you can see it's gray. When I hover over it, it becomes blue. And when I click on it, it becomes red. So that's what that styling does. I can even click on it through our text because of the visibility thing that we just set up. How do we hook up functionality to this? Well, making sure that our button is a variable, which by default it should be. We can go into the event graph, and with the button selected in our variables, we have a couple of events that we can do stuff with. So we have onClicked, onPressed, onReleased, onHovered, and onUnhovered. Well, the hover and unhover is probably pretty self-explanatory, but I'm going to just show you real quick with some print strings. So if we print string entered button and we print string left button, you will see that when my cursor goes over the button, it prints entered button. And when I leave the button, then again, it says left button. So those can be useful for navigation related stuff mostly. Maybe sometimes you want a sub image to change within the button if you're hovering over it, if you have like a special border system set up or whatever. Those can be useful for more or less just the visual flair. Generally not used for actual like functionality stuff, because that is where we get into onClicked, onPressed, and onReleased. I would assume that onPressed and onReleased are pretty self-explanatory as well. I'm going to print string these as well. Pressed button, and also then released button. If I press the button down, it says pressed button, and then it will only say released button once I actually release it. The thing is, if I press the button, I move off of the button, and then I release it, it will still say that the button was released, because the button was pressed down, and then it's just going to look at the mouse for when it is released, even though I might not be over the button anymore to begin with. That's where onClicked comes in. onClicked looks at whether you were on the button at the time of pressing and then also releasing. So you see, if I do onClicked, I print string and I click button, you see that I press the button and I enter the button. If I now go off of it and I release, it just says release button. But if I keep on it, it says, again, pressed button. It says both click and release, because onClicked only fires when you press and release both with your cursor still over the button. That is the functionality that you see in 99% of buttons in your entire life. That's going to be most of the time what you want to use for your normal user experience. Now, a few things to note. In a previous video, we made a special button with like text on it, I think, right? I don't know what we called it. I misspelled it. I called it a text button, no. If we look at this, I can provide in some text, like text for button, because we have that set up in that widget itself. If I now go into the event graph and I have this selected, you can see I actually don't have those events anymore, because this is not a button. This is a different widget that has a button inside of it, and that doesn't expose the events inside of it in the same way that just directly having a button does. So that can be a little bit annoying to deal with. So if we add back in my construct event, which I deleted before, I can get our text button and I can just get the button that we made in there, and then I can assign on any of those events as well, which will give us a event dispatcher to those events. That's one way of getting around it. Alternatively, what we can do is we can go into here and just make new event dispatchers that just kind of bind to these event dispatchers, right? So in this case, I really only care about onClicked, so we can on button clicked. And I can just say, hey, when this button goes unclicked, my new event dispatcher also just cools out. And then that new event dispatcher will indeed be visible on here. So on button clicked, we now have that. A really cool side effect to that is that we can add in extra information to our new event dispatcher. So if we want this on button clicked to have a parameter for which button was clicked, so like button reference or something like that, we can give our text button object reference through, and we can send through which button was just clicked. And now that event will also have the button that was just clicked. So we can print out the get text, for instance, from text block. So get text again. And we can print out the specific text for the button that was just clicked. So we have text for button, but if we also make one, this is a button, and we also add in our on button clicked to that, we can just kind of do the same thing here. Connect all that up, and now we'll have text for button being printed out when we press this one, and this is a button being printed out when we press this one. It's pretty small on screen, so I hope you can read it. But that's a bit of a workaround for having buttons inside of sub-widgets that you still want to be able to like bind some code to, which very often you will actually want to be able to do. If you're already familiar with wrap boxes, you might be using those to set up your grids in your UI, because they are responsive and they change how they wrap around and how they produce the grid dynamically. But sometimes you just want to set up a pretty hard-coded grid saying we have an X and a Y coordinate, and I can put widgets into those specific X and specific Y coordinates. I don't want it to do any like weird wrapping, because while this is dynamic and responsive, it also makes the layout of things rather unpredictable, because this is just a one-dimensional array that the widget displays in any way that it can. Sometimes you do want to have a final grain control over what you want to do, and for those we have the grid panels. So we have a grid panel and a uniform grid panel, and the main difference between the two of them is that this one is uniform. Go figure. So let's put both of them actually into this widget to see how they function. I'm going to put the normal one on top and then the uniform one on the bottom. So let's put in just an image like we've been doing for most of the examples in this UI series. And this image is going to go in slots row and column 0, 0. So this is just two arrays. You can think of this as a vertical box that has a bunch of horizontal boxes inside of it, all pre-set up for you. So if we copy over this image, for instance, these will both now exist in the 0, 0 coordinate. So if I set this to row number 1, you can see that it moves down. And with these grid panels, we actually have these built-in little widgets that can let you move these around. But you will see that even though I am trying to like increase the row, and here you can see the row number increasing, it isn't actually moving, because row 1, 2, 3, 4, 5, 6, 7, 8, and 9 right now are empty. So they don't actually take up any space. If I copy over this image again and I make this go down, you can see now row 1 has something in it. If I set this to render at a size of 100 by 100, now this row is, well, 100 by 100, as will this column be. But this thing over here, existing in column 2 and row 10, isn't aligned with this thing that is much bigger, so it still maintains its own size. And that is where we get into the difference between a grid panel and a uniform grid panel. Now, if we go over to this uniform grid panel, it initially will be a little bit weird in the way that it will present itself. But if we put in an image into this, and I just set this for demonstrational purposes to horizontal and vertical fill, it will fill the entire thing, because it's only got the one cell that's actually being filled out, so it's filling out the entire thing. But if I put in another image with it, and say that this one needs to exist under it, you can see that it tries to keep all of these cells the exact same size. So since we only have this one column, it still has the cells being the width of the entire widget that we have here, which we can just we can make this widget as big or as small as we want. But since we have two things on top of each other, we have two rows, so it makes each cell in this column the exact same size. So we can set this to fill horizontally, sure, fill vertically as well. The cell size is going to be decided by the biggest element in there. So if we add something else, let's add a button, for instance, to this. And I want to move that over here. You can see that it tries to now make these cells such that they form themselves into a shape where they divide evenly between the amount of columns and rows that we have. Meaning that if I move this around, it does actually make these new empty columns when I move this further and further to the right. Unlike this normal grid panel, which will add the columns, but since they are entirely empty, it's not actually going to like show it moving. So this uniform grid panel, in a lot of ways, feels like it probably works a little bit more intuitively, especially if you're going to work with blank space. But it also, much like the wrap box, because it is doing stuff for you, sometimes that does mean it deals with things in unintended ways, which means that just doing it with a normal grid panel might actually be preferable. For both of these, you can also, of course, add things dynamically. You just need to make sure that they are set to being variable. And then coming into your event graph, we can get the uniform grid panel and the grid panel. And you can just add a child to grid. And there you can give in your contents, any widget that you want. And you can give in the exact coordinate of where you want to add those things. So the row and the column that I want to add things to. Again, if you're doing this for like an inventory or whatever, you can say my inventory has a width of 5 and a height of 10. So I have 50 slots in total. And I'm going to populate them like this instead of with a wrap box. And you very easily still can just take an array and go through it linearly and put those things in here. So what you could do there, just to show you real quick, as an example array, can be booleans, it doesn't really matter what we do, honestly. I will make an array here and I'll give that a handful of elements. It doesn't really matter what their values are. I'm going to go for 25 elements, so that's a 5 by 5 grid. And then on pre-construct, which we have somewhere around here, surely, maybe not, pre-construct. I'm going to for each loop over this array. Well, first I'm going to clear all children out of this grid panel. And then I will for each loop over this, so for each. And what we can do, we're going to want to fill this from the top left going to the right and then wrapping back around, right? So we first want to give in which column we go into and then which row. We modulo this by 5. So this is going to divide by 5 and give us the remainder. And then the row, we just do a clean division, also by 5. And for that, we'll just make a construct object from class. I'm just going to do like a text or something, which is somewhere in here, surely. There we go, text, found it. There's a lot of things that have the word text in it because texture obviously also has text in it, so it's hard to find. And then we'll set the text in that to be equal to our array index. And that is what we'll be adding here to our grid. So now it should take an array and fill that out in our grid automatically, which it does do. So you can see it does 0, 1, 2, 3, 4, and then it wraps around to 5, 6, 7, 8, 9. And all of these have their own proper coordinates. Of course, we could then set the padding for everything a little bit and just set it to like 5 on each side or something like that, so that they're just a little bit further apart, so that they're a bit more readable. But that way you can still take a one-dimensional array and put it into a grid and have the grid actually function a little bit more like constrained as a grid instead of using a wrap box. You might have heard me talking about certain things being sized certain ways and the limitations with that in stuff like maybe like the horizontal boxes, right? When we put a button into a horizontal box before, so we have a horizontal box and we put like a image into it and then we put a button into it, the button will automatically just size to whatever content is in it, which is a little bit too bad. What if we want this button to not have any content in it or be bigger than the text that we give into it or whatever? How do we set that up? Like at all? Well, for that we have size boxes. A size box is just a parent widget that can hold one thing. and it will just force whatever is in it to go to the size that we give it in. So let's put in a size box into this horizontal box and then put our widget button into that size box instead. Now, if we select the size box and come over to the child layout here, we have a handful of different things that we can do. What I end up using more often than not is just the width override and the height override, where we can just say, hey, I want this to be a certain width, or I want this to be a certain height. Now, obviously, if we do want to override the width and the height, we need to make sure that these are not set necessarily to filling their whole vertical space, and then we can see that it will work with setting these sizes. So now we can set this button to be maybe like a little bit thinner, and maybe we'll align it to the center, and wider than it would usually be in this size box, which is really nice. Now, this is pretty hard-coded, obviously. This is just, it's going to be this size no matter what. Even if we make this horizontal box like bigger or like smaller, it will always just be that size. And sometimes that is what you want, but sometimes you do want it also to be a little bit more responsive still. So for that, instead of using these, what we can do is we can use the minimum desired width and height. So now we can say, well, I actually want you to be at least this wide. But if we put some more content into it, so in this case, let's say a text, you can actually become wider than that. The same with the height. We can say, well, I actually want you to be at least a certain amount of height, but you can grow bigger if you want to. At the same time, we can also set a maximum desired width and height. So I can say, well, actually, I don't want you to be any like higher or wider than this. So we can still limit its size while having it be a little bit more responsive to the content inside of itself as well. In the same way, if you don't care about specific size information, but only about the aspect ratio, we do have possibilities for that as well. An aspect ratio of 1 is just square. An aspect ratio of 2 is allowing it to be twice as wide, and obviously I would need to do that in the max in this case, twice as wide as it is tall. So for a normal like 16:9 video, like you're watching right now, the aspect ratio would be about 1.66. This is roughly the aspect ratio of a YouTube video. Depending on how you're around, you might say 1.67, doesn't really matter. If you're going to like the cinema, for instance, off the top of my head, the widescreen aspect ratio that you see there, or with like super widescreen monitors, is closer to 2.1. So this is the ratio of width to height. And we can say, well, actually, I at least want this to be 3 times as wide as it is high, but no more than 5 times, right? So now if we do that, and I go in and add some more like gibberish to this text block, it will start growing, but only to a certain extent. With this, we can more accurately set up the constraints of the size of any given widget. If you've ever seen me working on widgets during like live streams and that kind of stuff, I use these size boxes maybe unreasonably much. These are really useful tools. But there is also a variation on the size box, that is the scale box. So let's actually put this size and the scale box side by side here and show you what the difference is. Because this is only the size that is going to hold a child widget. The scale box will actually scale what's inside of it as well. And with things like a button that usually fill the entire horizontal and vertical space of the box that they put inside, that doesn't really make a difference. But if you have like an image, like a texture, for instance, that you put in both of these, you will see. If I also set this image to be aligned to center, vertical, and horizontal, and this one also is aligned to both of those, even though this is not set to filling or anything, as I increase the scale box, the image inside of it scales with it. It maintains its normal aspect ratio. We can set it to stretching in any direction to like fit only the X or fit only the Y, or no stretching at all, or to fill or whatever. By default, it's set to scale to fit, which is just like normal behavior as you would most likely usually want it. Compared to that, if I increase the size of this size box, it doesn't actually scale anything with it. Of course, we can set the image to fill horizontal and vertical, but now it's going to get stretched as well if we do anything with that. And just to show you that a little bit more, if we actually put a texture into this instead, you can see that the texture is going to get like stretched and squashed as I change this thing around. As opposed to this, where a texture being put into it, unless I specifically set this up to stretch, it's going to maintain its aspect ratio as I scale this up. So for things like scaling up textures in a box like this, a scale box, it's in the name, makes a lot more sense. Again, both of these can only take in one child object each. So if you want multiple, you're going to have to make them like in a vertical or a horizontal box or a wrap box or whatever. But very often I will end up using these size boxes specifically for things like buttons or in sub-widgets so that they are at least guaranteed to have a certain size. We've talked a lot about showing players certain things and even had buttons for player interaction. But what if we want players to be able to provide information to our systems to do stuff with? So today we're going to talk about the first of the player input stuff that we're going to be talking about in the next couple of videos as well. And that will mostly be things like sliders. A slider is very easily just a thing that a player can interact with, which will output a value from 0 to 1. So if we go into the event graph and I add back in my tick event and I get my slider, I can get the value from my slider. And as you can see, it also has a minimum and a maximum value. So by default, it gives you a value between 0 and 1, I should say. But you can set this value to be anything you want. You can also make the slider vertical if you want to. That's very fun. So if we just print out the value that we have here, and we're going to be printing it for duration of delta time so that we don't spam our screen full, you will very easily see that we have the slider prints out 0, and that goes up to a value of 1. If I then go in and set the minimum value here to, let's say, 100, and then I set the maximum value to 800 as just a random example, you will see that it doesn't immediately work because its default value is 0. But then if I even just touch it, it goes to 100, and then again, it just interpolates between the minimum and maximum value based on the distance of the slider. So that is pretty straightforward, I would say. Let's set this back to a value of 0 to 1, because I'm going to show you a progress bar as well. A progress bar isn't something that you really like interact with, but I didn't really want to make a separate video about just a progress bar because these things are ridiculously simple. A progress bar is just kind of like the opposite of a slider. You give in a value between 0 and 1, and then it fills itself in with the color and opacity and all that kind of stuff that you provide it in with. So if we in event tick also set our progress bar, we set %, and we set it just to the value of our slider. You'll see as easily as that, it will just match our progress bar to whatever we set our slider to. This can be useful for very basic HP bars. The moment you start doing like more fancy stuff with your HP bars, it might make more sense to render them onto an image with a dynamic material. But for very basic like HP bar stuff, especially for like prototyping, this works fine. And you can do some more fancy looking stuff with this in the appearance as well, I believe. Like you can turn this on and that makes it kind of like fancy, more like a loading bar, right? You have different scale types for masking or for scaling. You can fill it in a variety of different ways, left to right to left, fill from the center, which is really kind of weird, but that's a thing that you can do. The top to bottom, whatever you want. There's a lot of options with these progress bars that you can just play around with. Going back to the topic of sliders though, you should also note that we do have a radial slider as well. And this essentially is just a normal slider on a circle. You can say where on the circle it needs to start and where on the circle it needs to end. So you can have just like a part of a circle, like a bit of a curve. It's just a bit of a fancier way to include a slider if you want to. This one also has a slider hand that it can show, just from the center to wherever the slider thing is. I don't personally love showing that, but that's a thing that you can do. And this works just as you would expect it to. You pick the handle and then you actually like can move it around in whatever way you want. Just left to right still does work. It gets a little iffier when you have like a super long radial slider, at which point you might actually need to start like making radial movements, because just doing this doesn't quite work, right? So now you actually need to start like doing this radial movement in order to move the radial slider. This slider's range, for some reason, is driven by a curve instead of just an input and a output value. So that's actually really quite useful, because that way you can make the first bit and the last bit maybe either add more or less aggressive values and have the middle bits just kind of be more consistent, right? So we can say this is just a value of 0 to 1. But if I set the value at time 1, time is just the axis of the slider itself. But if I set this to like 500, for instance, and we scale this back to normal, I can add in multiple extra keys. And let's say that the first 10% will only go from a value of like 0 to 10. And then the last 10%, so from 0.9 to here, will do the last like 50. This is a really kind of like weird curve. Well, let's do it the last 20. There's a really kind of weird curve where the start and the end don't really add much to itself. But if we now hook this one up to our print string, and if we then get the value, let's use this function that we have for that here, and we put that into the print string instead, we'll be able to see that it does do like up to 10 for this first bit, but then it very quickly starts doing much more, and we get to like 490 here, and then it starts doing much smaller increments here at the end. We could also set this up to maybe toward the end here, instead of going all the way from like 480 to 500, we can say, well, actually we want 90% to just be 500 and then 1000 for the last 10%, right? Just to show you that it does that. So this just does the same linear interpolation, but the moment we get to like 500, you can see the last 10% does a bunch more. That goes all the way up to 1000 now. So this one responds to a curve, whereas this one is just linear interpolation, which means that this can be a little bit more useful. Frankly, I would actually enjoy it if this one also could respond to a curve, but doesn't seem like it can. So that is sliders and progress bars. Mostly sliders, progress bars just kind of thrown in there because it thematically fits. Over the next couple of videos, we're also going to input text and have drop-down menus that we can create. While we've already talked about sliders and how to give in numbers with those, we also are going to talk now about how to set text from a user perspective, and a slightly different way as well of setting numbers. So let's get rid of these real quick, which I did in the previous video. So if you haven't seen that one, go check it out. But for now, I want to show you the editable text. So we have a normal editable text, a editable text multi-line, and then we have boxed variations of those as well. The only real difference between the boxed variations and the non-boxed variations already is visually obvious, I hope, is that the box variation just has a background. So these are a little bit more flexible, making things look the way that you yourself exactly want them to look. These come with a little bit more like pre-done stuff, but obviously will be slightly less editable as a result of that. But functionally, they will be the exact same thing. And it really is quite simple how these work. If you go in and you click on them, you can type your text. And with the multi-line one, you can just type text, and when you press enter, it just goes to a new line. It really is that self-explanatory. So how do we get the data out of that to use in our blueprints? Well, if we go over to our event graph and we go to literally any of these four, they have the exact same events on them. We have both onTextChanged, which I will do a print string for, and we'll just print out the text changed. But then we also have onTextCommitted, which this will run anytime I change the text. So pretty much anytime I add a new character or delete a character from the text, this will only run when the text is committed. So when I press enter. You can see this also has a commit method. We can see the different values for that if we just do an equal enum. This is default, or when we press enter, when we move the user's focus away to a different widget, or when we just clear the entire thing out. Those are the commit methods for onCommit. For this one, I'm also going to just print string the text, but we're going to append the word committed to it. Just misspelled, because that's how I do. And this will be the editable text box _0, which is this one up here, the top one. So you'll be able to see that as I start typing in that, it just shows the entire words that I have typed in so far every time I type a new character. The moment I press enter, it types whatever I typed and commit it. Now, it did it twice there because I pressed enter, and then also when I pressed enter, it shifted my focus away. So it triggered both of those things. We can actually see that as well if we try to append this enum to string. We're able to see that I can do all this, and then it has enter and cleared. So it's not actually shifting the focus, it's technically clearing it because I no longer am typing in it, I suppose. I'm going to be honest with you, I've never actually run into a situation where I'm using this commit method for any sort of logic at all. It's nice that they give it to you, but for the most part, it doesn't really matter. But of course, this would be useful for things like setting a player's name that you can then store in a variable in like your save file, and then you have a name for your character. Now, it does output text, and I don't know if I've complained about this in a previous video or if this was on a live stream at some point. I find it a little weird that this outputs text, because text is a specific variable type that's supposed to integrate with Unreal's translation system, but these editable text boxes are mostly for taking in user inputted text, meaning that you as a developer aren't going to have that in your translation table. So unless you want to like create pre-existing words that it will auto-translate, I suppose that might be useful. For the most part, I don't really see the reason that this is a text. If anybody's watching this and has a good reason for these to be texts rather than strings, please do enlighten me, because I really don't see the use of these being texts. If you're curious about the difference between texts and names and strings, by the way, I do have a full video on it. I'm going to try to remember to add that in the description and as a clickable card on this video. If I didn't remember it, again, scream at me in the comments about it and I will link you to it. But those are the simple, straightforward ways to add text fields into your game. So this is a text field that you can just type away larger paragraphs of text in, and this is more of a thing where you can like type in names and that type of stuff for characters. Now, one little bonus that I want to throw in here, because this video is relatively short, we also have this thing called a spin box. And the spin box is just a thing that lets you put in a value, a float. So it's really as easy as you might think. It's just more or less the exact same thing that you actually just have on these, right? These are spin boxes, if you think about it. It's just 3 different spin boxes to make a vector. And that's exactly how these spin boxes work as well. Of course, you can set a minimum value and a maximum value to clamp these two. So I can say, well, actually, if I use this for like field of view, for instance, you probably use a slider for field of view, but let's just imagine that you use a spin box instead. You can say, well, I actually want the minimum field of view to be like 50 degrees and the maximum to be like 110. So then you can see that the minimum it sets to 50. I can't have it under 50, and then it can go up to 110, but can't go above it. We also have separate slider minimum and maximums. So we can say, well, actually, if I'm using the slider, I want the minimum to be 70 and the maximum to be 90. So that way, just sliding it back and forth will clamp to 70 to 90. But if you manually enter in values, you can go down to 50 and up to 110, but they will still be clamped to those. So you'll see that right now, I can go from 70 to 90, but I can also just click on this and give in a value of 60, and that will work just fine. However, I cannot enter a value of 30 because it's going to clamp it to 50. And then, of course, when I try to use the slider, again, it's going to clamp it between the 70 and the 90 that we gave in. So this spin box is kind of like an in-between between sliders and text boxes in a certain way. So I wasn't sure in which video to include it, but this video is a lot more straightforward, a lot shorter, so I figured let's throw it into this one. In the spirit of user inputs, we've talked about sliders and these text fields already, but sometimes you just need to have a drop-down menu with a handful of different options. And well, that's also fairly easy to facilitate because Unreal has this thing called combo boxes. We have a key variant and a string variant. For the most part, the key variant is a little bit more of a hassle to set up, but slightly more customizable. And in the end, also technically slightly more performant. And then we have the string variant, which is a little bit more straightforward to set up, but it uses strings, and people hate strings. So it's a little more good for like quick prototyping in a lot of cases. So what do we have here, right? We have our default options for the string combo box. So let's just give it a couple of options. Let's imagine that these are graphic presets or something like that. So we can say we have a low option, we have a medium option, we have a high option, and we have a ultra option. If we just go into the game now, we can just see that there's already like something wrong with the key-based one. We'll get into that in a moment. But we just have our low, medium, high, and ultra drop-down menu, and we can just pick them, and that is that, right? The visuals for them are a little bad by default. You can give them sounds and all that kind of stuff, but we have this combo button style, so shadow and color opacity. What I want is the item style. I want the text color to be white, because I don't know who thought that gray on black or black on gray was a good idea, but this is a little bit more readable, right? So that's pretty straightforward. And how do we use that information? Well, if we go into the event graph, we get our combo string. We have on opening, so this is whenever you open your selection box. If you want to do something with that code, you can. Generally speaking, I don't really see a lot of things that you would do when you open a combo box, but it is an event that you can use. And we also have on selection changed. This is when you change your selection to something new. This has a selection type enum, so we can check whether that was based on a key press or based on navigation, when we click a mouse, or when we set it directly through code. This one is slightly more relevant than the last video that we did on the text inputs, because in this case, this will also change when you like navigate with a controller over it. And in some cases, you might want that to immediately update to reflect like maybe a different post-processing effect or something like that. But maybe if you do like your entire engine scalability, that takes a moment to update. You don't want that to instantly update anytime you scroll over all of your options. You really want that to be like properly committed to before you do anything. So these might be a little bit more relevant to use in combo boxes. Now, the more important thing is that we get the string of the selected item. So what you probably do is you add a switch on string and then just switch on these different cases. And then in the details panel for it, you can actually set the strings that correspond to it. Now, do make sure that these are actually like 100% the same. So the best thing to do is just to come in here and copy these over and paste them back into there, so that you are entirely sure that you didn't do any typos, you didn't do any misspellings between the two of them. They are the exact same thing, because with strings it is quite important that everything matches up, otherwise it's going to go through to its default output pin that we have here, which is also good to set up something for, just to catch whenever you mess up any of these names. But let's just copy all of these over, so that we're entirely sure that whatever happens, it's always going to be one of these. And then you could like set engine scalability relative to maximum, which is a pre-existing function. And this is the lower the number, the higher your scalability. So for ultra, that would be 1, and then high would be 2, this would be 3, and then we'll have 4 as well. And now we have a combo box that can set our engine scalability. So if we do this and we set this to low, we can see it instantly changes the graphics to look quite a lot worse actually. So let's add it back to this, and we can see that it does those in slight steps like this. So we have a combo box that sets our engine scalability now. Fantastic. So that's what string combo boxes do. Now, there is an argument to be made that strings are slow to compare. So a switch on string is a pretty slow operation. My response to that also would be that because this is like a user UI thing that you're going to put in like your settings menu or whatever, it's only going to do this once. It's not going to do this like 100 times across several different instances, every frame or whatever. So the string compare being a little bit slow here probably doesn't actually matter that much. However, we're still going to take a look at the other option here, because that one uses names, which is technically more performant, but more importantly, it has a bit more customizability to it as well. So what we have here, if we scroll all the way down, we get a onGenerate widget. We can create a binding, and that will take in our item. So that's going to be the name of whatever we put in. And we can return a widget. So instead of just having the default string on a background that we have here, we can actually make these display custom widgets instead. So in my case, what I'm going to do here is I'm going to make a super quick little widget, user interface, widget blueprint, WBP. We'll call this choice widget. And all that I'm really going to do for this is I'm going to give this a border. And in that border, I'm going to put in a text. And that's really all there is to it for this. So the text I'm going to make white, and the border I'm going to give a default color of like green, something like that. Set this to desired so that we can actually see what's going on a little bit better. And then I'm going to make both this color and the text itself, obviously, be variable. So make sure that both of these components themselves are set to being variable. And then on event preconstruct, I drag both of these in, and I set text for my text on preconstruct. And then I set color, set brush color, that's what we want. And I promote both of these simply to variables. So we promote this to a variable. We promote this to a variable, set both of those to be instance editable, and also exposing them on spawn. So that way, if we go back to the WBP HUD on generate widgets, we can just create a widget. That'll be our WBP choice widget. Takes in the text for the item. And then in this case, we can do whatever you want with the brush color. You can of course do something like a switch on string here as well and make different widgets based on your like string inputs. So that way well actually let's just do that. Can I just copy over this switch on string? Hopefully we can. You can. Fantastic. So that way what we do is we return different widgets based on the input string, right? So on low we return this with a like light blue color because it's not that intense. We always return the like input text, but on medium that might be like a slightly more green color, and then on high that might be like a more orange kind of color, and then ultra is going to be like super like saturated red or something like that. And then based on whatever input string we give in, it's going to have the different colors as well. So you can see, even with this string box, we still have quite a bit of flexibility to code up our own customized setup. So we'll be able to see that if we now look at this, we have these different colors for all these different backgrounds. And I'm using the same widget now with just different input parameters, but you can make these entirely separate widgets, obviously. So it is quite customizable as it is, but now let's go over to the key box, because that is a slightly different story. We still have this onGenerate content widget, which I can actually just create the same binding for. It technically gives you in a name instead of a string, which again is more performant. So we would have to switch on name instead. So we name those low, medium, I'm just going to say low, med, high, ultra, all that same stuff. And we kind of just like copy all of these over, because it's going to be pretty much the same deal. But instead we need to convert the name to a text instead. And that's pretty much as easy as it is. The only difference there being that this is, again, technically more performant, but not in a way that's actually going to matter. So I wouldn't like lose any sleep over it personally. Let's return all of these values as well. So this is the exact same thing. So why is this better? Why is this more customizable? Why does this, why would I use this over the string one if the performance difference doesn't really matter? Well, the thing is, you saw that there was a second thing that we could generate a binding for on this one, didn't you? We also have generate item widget, and this we can use the same binding for now, is going to generate the widget that displays inside of here once we've picked something. That is a thing that the combo box for string just simply doesn't let you do. As you can see, if I pick medium, it just picks the same medium one, or ultra, or low, or whatever. I didn't actually give this one any options. Hold on. Let's go back into the options. Call this low, medium, high, and ultra. And this initially seems like it works the exact same way. But what if I just want this to be non-colored, or always want that to be like a black background or whatever? So what we can do there instead is we can create a new binding. And I'll just use one of these create widget things because I don't really care about making a new specific widget for this. And I'm going to say this one always just has a black background. So I don't want any fancy colors once I have it selected. And now you'll see, unlike this one, which always will just show you the corresponding color from the drop-down menu, when I choose this one, I set it up the wrong way around, but it now shows everything as being black, and only when I pick it does it show you the color. I just mixed up the two different functions here. So what you'd actually want to do is go back into Designer and swap these functions around, obviously. So we have onGenerate widget contents will be onGenerate item widgets, and the other way around. I mixed up which one does what. So now this one will always be black, and these ones will always be colored. So you can set up different widgets for choosing and having made a choice, which is potentially just kind of nice. Especially used with a combo button style where the combo button itself is kind of just like invisible. So we can say the button style here. So if we set these normal, hovered, and pressed styles just to have a tint with a alpha of 0, you'll see that we still have the little arrow drop down next to it, which you can also set that up to not show, obviously, if you don't want that. But that way it starts looking like not programmer art at some point. Obviously, the widget that I made still looks like programmer art because it's very ugly. But we don't have this outline anymore, and it starts looking a little bit more like exactly what you want it to look like. So that's combo boxes for you. For the most part, the string boxes probably will do all that you need them to do. But if you do want that little bit more visual customizability, the key boxes are really quite cool to work with as well. The expandable area in Unreal widgets is actually quite cool to work with, because what an expandable area is a widget that effectively just has two named slots already in it. One for the header and one for the body. So we can put in, for instance, just a little bit of text for the header, and we'll call this the category. And then for the body, we can add in maybe a border. Within that, a vertical box that then has a handful of texts in it as well. And you'll notice that we don't actually see these texts yet. But if we go back into this expandable area and we set is expanded to being true, it then, well, expands everything in the body. We also do need the actual expandable area to be as big as all of its content. And then maybe set the border here to being black. That's the content color. We need the brush color to be black and maybe somewhat see-through instead. And we could even do something like wrapping this with a horizontal box. Just having a little bit of fun at this point, right? And then in that horizontal box, we'll put in a spacer as well. And a spacer I don't think we've talked about yet. I don't know if I'm going to make a separate video on it. But it effectively just works as an object that forces in some padding. So it's an empty object where I can just say, hey, padding to the right, let's say 15 units. and then everything is padded out to the right by about 15 units. And so now with that, we have a expandable box that we can expand in and out very, very easily like this. And you can see that this is really already something that you can use to make things like a tree viewer. Unreal has a built-in system to build tree viewers where you have categories that you can like expand and unexpand. About it in the future, I don't much love the implementation that Unreal does for its like list view and tree view system. For a lot of use cases, so building your own tree viewer with these things instead might make a lot of sense. Because if we have these expandable areas, and instead of adding in this vertical box a bunch of texts, we just add in more expandable areas, you can kind of see where we're going with this, hopefully. We have just like a couple of more expandable areas. Make this border maybe not as small, setting this to fill. And then all of these expandable areas can be their own categories. So let's give these texts, this header will be right there. Obviously, we would make the font size for this one a bit smaller, like half the size. So this would be like 12. And then we can just copy and paste that into all of these headers. And then all of these can have like even smaller text inside of them, like font size of 8. Let's just copy in, well, those would need to be in their own vertical box, obviously. So wrap with, vertical box, and then we can just copy in a couple of them, and then those can be the bodies for everything here. And now we effectively made a tree view. I can expand or collapse this parent category, but also any of the child categories. And if I do expand and unexpand the parent here, the state of the child categories will remain the same as it was before, because it's not actually like deleting anything at all, it's just not rendering it anymore. So this is a way that you could very easily make your own custom tree views that probably works a little bit better than Unreal's built-in tree view system, which again, we'll make a video about in the future. So that's the expandable area. It's really quite straightforward and really quite simple. I suppose it's good to note that if I select one of these, I can add an event on expansion changed. So if you want to have any code related to any specific expandable area, it will give you an object reference of the area that was just expanded and whether or not it is now expanded or collapsed. So you can hook up some code to that if you so desire. I want to talk about the widget switcher today. So this is an area that can hold multiple different sub-widgets that you can, well, as the name implies, switch between. So let's take a look at that. I'm going to make a horizontal box inside of it, and then I'm also going to make a vertical box inside of it, and then we're also going to just make an image inside of it. And we'll fill both of the horizontal and vertical boxes with some buttons so that you can see the difference between all of the different widgets that we have here. So copy these buttons, paste them in there, and you can see as I select the sub-widgets, it shows the one that I'm currently working on, so that's actually quite useful. But how do I switch between these in the actual gameplay? Because if I now go in game, we see I have my horizontal box, but how do I switch this over to my vertical box? Well, for that, we go into the event graph, and there we have widget switcher, and then we can just switch active widget, or set active widget. We can either do that based on an actual widget, or set it based on an index, so set active widget index. Obviously, this is effectively just an array, right? So this is index 0, index 1, index 2, and so on. So let's make a quick little extra button on this UI so that we can trigger that. I'm going to do that outside of the widget switcher, because obviously I don't want it to be lost when we switch to a different widget. And whenever we press this button, what I'm going to do is I'm going to get the current active widget index. I'm going to add 1 to that because we want to move up 1. And then I'm going to modulo that with the length of the array so that we always get something between 0 and the end of the array. So we get number of widgets, and we just put that into the bottom for the modulo, and then we set that as the new index whenever we click. And with that, we can now cycle through the widgets like this. So just pressing the button, it cycles through all 3 widgets. Obviously, we can also make one where we decrease, like go the other way around. So we just make another button again. And we set active widgets to effectively the entire same thing, but instead of adding 1, we just subtract 1. So we add -1. Maybe a subtraction node would be better there, but I already had this entire thing to copy over. And adding -1 is the same as subtracting 1. So now we also have a button that lets us go through the other way. So we can go through either way. This one doesn't wrap around because technically it's going into a negative number, and that doesn't really work with modulo though. But that's not really the point of this video, I don't think. If you really want to make it deal properly with that, we get our active widget index and we add the number of widgets to that, and then we subtract 1 from that instead. That way it will cycle through with wrapping to both areas without any problem. Again, this is just some like general math stuff that we don't really care too much about. But that's the widget switcher. It allows you to switch between widgets. Now, it just hard cuts between the widgets. It doesn't have like any animation. So if you have any like fancy settings menus that you want to animate in and out, this might not be quite everything that you want it to be. And you might still need to set up a more complex like set of different widgets that all animate in and out. And we're going to talk about widget animations in a different video. But for just hard cutting between different setting menus, this is actually really quite useful and quite good. And if you don't need it to like be all fancy and animated, this will really save you a lot of headache. The list view in Unreal Engine is a thing. It can be really useful, but it's also a little counterintuitive as to how to use it. One of its really cool things is that it also comes with a tree viewer, but I personally gonna go ahead and say it, don't really love the way that it works by default, so I'd rather make my own tree view, but it is there if you want to use it. So we have 3 different list views. The normal list view I actually do find to be quite useful. The tile view might as well exist as well. This is still pretty good for things like inventories. It's kind of like a wrap box, but with some more like automated filling in of its contents. And then we have the tree view, which we'll talk about last because it's a little goofy in the way that it works. So how do we set up any of these list views? Well, for that we first need a widget that we're going to use to populate it. Unlike things like the vertical boxes and horizontal boxes and wrap boxes and all that kind of stuff where you can just put in different widgets, what you do here is you put in different objects, whether that be assets or actors or whatever, and those will be represented by a specific type of widgets. So let's go ahead and make our user interface widget blueprint here, and this will be our WPB list item. And for this list item, what we'll do is I will make this a horizontal box, which will take in a image, I think. We'll put it in there. Let's also set this to be desired on screen, or just desired. And then I'll put in a text as well for the name of whatever this item is going to be. Let's pretend like we have an inventory system, right? And then we also have a text for the amount. And there's going to be a little bit of padding between those, obviously. So to the left, let's like 15, 20 units of padding. This text block we're just going to set to a X. And then one more text block after that, and that's going to just have like 5 units of padding or something like that, and that will be the actual like name, so or amount. So this will be the amount. The text block will be the item name, and obviously the image will be the item icon. So we can set this up in the event graph. On pre-construct the item icon, we'll set that to brush from a texture. The texture will be promoted to a variable that we're going to set to expose and spawn and instance editable. And then the item name, I also need to make variable. One little thing that you can maybe see here is when you create one of these and you set it to variable, it'll actually be bolded text, and everything that's not variable is not bolded text. So that's a nice little thing to easily see what is variable and what is not. But we will set the text for this as well. We'll just make that a variable for the name. And then we make the amount, set that to something as well. So set text. But for this, we're going to do int to text. And we'll make the integer a variable instead. And for both of those variables, instance editable, and also expose them on spawn. In our case though, expose on spawn actually isn't required at all because the list view is going to be spawning these things in, so we never actually see the spawn in node for these. Now, how do we get this widget into our list view? Because we can scroll down here and that says our entry widget class, and we have nothing to pick. And that is because that only shows widgets with a certain interface implemented. So to implement an interface, we can go into the class settings of our list item widget blueprint, go into the implemented interface and add the user object list entry interface. That will allow us to add a couple of different things here in our interface functions. So we have on entry released, on item expansion changed, on item selection changed. The item expansion change is mostly what the tree view works with. Again, I don't personally love it, but it's a thing that you can do. But in our case, the thing that we really care about is on list item set. So instead of doing this on pre-construct, what we do is we get our list item object. This can be any sort of object that we put into it. In our case, if we're doing this with an inventory system and that inventory system runs off of data assets, which if you want a data asset based inventory system, I have an entire course for that. That's what's going to supply these values in instead. So we don't actually even need these as variables necessarily. So let's actually just remove these as variables and make a data asset for this. So we make a blueprint class and we look for data assets, primary data asset. You can make this as a basic U object as well. It kind of depends on exactly what you want to populate this with and what system you want this to integrate with whatever you've coded up yourself. This will take in literally any U object you want. So any asset, any actor, any component, anything in the entire game, in your entire project, can be used as an input here. We'll call this DA item. And that's then going to have those same values, right? So it's going to have an icon, which is going to be a texture. If I scroll down here, we'll surely find the texture 2D. Object reference, going to be exposing that. We'll make a name. It's going to be a text because it needs to be translatable. And in this case, obviously, if you have a inventory system, using data assets, again, check out my playlist for that if you're interested. You wouldn't have the amount of items that you have of a certain thing on the data asset itself. You would have that on like a inventory slot type of struct for an array. In this case, we're just going to example count in this thing right here. And that's going to be a integer. Again, this is not representative of how you'd make an inventory system necessarily, but as an example to show you how list views works, it'll have to do. Then we can make in our miscellaneous a data asset of our type DA item. So we'll call this item 1 or just item, and we'll give that an icon. So that's going to be like this one. The name will be item 1, and the example count will be 75, just as something to show up. We'll make item 2 as well, and then item 3, which will give different names and different icons and different counts, just to show you how everything works. So count for this will be 332, because that's where my fingers were at. And then this one will have like the Unreal Engine logo. It'll be called item 3, and it'll have 123 as its count. So now that we have that asset class, that object, this list item object is going to be a generic object, so we still need to cast it to our data asset item. But then we can get the icon out of that, and we can get the name out of that, and we can get the example count out of that, and we can supply that into all of these. And now, whenever the list adds in a item, so the items that we're going to be adding in will be the data assets. It won't be these widgets. We'll be adding in these data assets, and whenever it adds in one of these data assets, it's going to be creating a widget and supplying in a reference to the assets that we are adding to the list, and we'll make these widgets with the corresponding data. So going back into our HUD, we have our list view here. We can now try to do our entry widget class again, and since we implemented that interface, it now shows you that thing. Now it has a number of preview entries. If we actually go into the game, it doesn't have those anymore, and I had some leftover code here apparently. Oh yeah, it doesn't compile as long as one of these things doesn't have an entry widget class. So let's just make entry widget classes for all of them. And as you can see, obviously this tile view, well, puts them into effectively what is a wrap box, right? And this tree view will also allow you to expand these to like show more data for them or whatever. I'll get back to the tree view in a moment. But as you can see, if we now actually play the game, it doesn't show anything because those 5 little things that it adds here are just for preview purposes. What we need to do is we need to go into here, and I'll add a event construct, and I'll get my list view, and I can add an item to that list view. And that item can be pretty much anything in the entire project, obviously. But we know that for this list view, what we are trying to get in is our item data assets. So let's add in item 1, and then also item 2 and item number 3. So we're adding in these assets to this list, and then the list again will make those widgets and provide in those assets to those widgets to do with as they need to do. And then we can see we make this item 1, we have 75 of, whatever, right? So this list view is now showing a view of a list. The list view itself has some built-in padding with either horizontal or vertical spacing. So I can set the vertical spacing to like 5 or maybe like more like 15, and then we'll space them out automatically here with the vertical spacing. Obviously for the tile view, the horizontal spacing also comes into account. So if we look at where that is again, I always lose where this is kept because you can just look it up like this with spacing. We can give these 25 units of spacing, both horizontal and vertical, which will just give them the spacing as you need. Obviously this tile view is mostly for things that are actually like square shapes and not these like list entries that I made for it. But that is the list and tile view. Tile view just works the exact same way as this list view would, but it just displays them as tiles. Now we have this tree view, which is slightly different because we can just add the items to the tree view if we wanted to. Like that's not a problem at all. Like that just works, and it will show them in the tree view. Let's make a little bit of room for the tree view actually, just so that you can see it expand as we go. So there's one over the right here now is the tree view. The tree view also has a function on it to expand a given item. So we can expand all very easily, but we can also set item expansion for a specific item, which takes in a specific item, which again is just any objects in your project effectively, and that's whether or not it is expanded at that time. So what we might want to do is have a tree viewer widget that itself has a button in it that can toggle its own expansion, report that back to the parent widget, and then the parent widget can expand or collapse that tree view entry. You kind of see why I'm not a huge fan of the way that this works, because in my opinion it's a little bit convoluted making the tree view work. For list views I actually quite like the way that this works, because you can just give in a data asset or whatever and put that into a like widget format and everything will be taken care of. The tree view is a little bit convoluted, but it is easier than setting up your entire own custom solution for it still. So let's make a variation of our list item here and call that something like WBP tree item. And the most important difference for that one is we're just going to add in a button at the very beginning here. So that's just going to be a toggleable button. Whenever we press that button, what we'll do what you can do is you can get a list of all items. So get list items, which is just a object reference array, which we will for each loop over. And this is where we get into why this is such a pain, because we're going to do this all based on the items. We're not going to drive this with the widgets. We're going to drive this with the objects in the lists, because it is a massive pain in the ass to actually get a list that is accurate of the widgets that this tree view has inside of it. So what we do instead is we have our item list, which is our data assets. That's these three things, instances of this class. This is going to be the thing that we tell to expand and unexpand, and that's going to be the thing that we like listen to. So on our data assets, we're going to add an event dispatcher for expand, and we'll add in a variable for expanded here as well. Obviously, this makes a lot more sense if you're doing this with like just a basic U object and you're instancing those instead of using these assets. Again, you probably need to make an inventory system where your inventory slots are U objects, and then you give in that entire U object, and you would have this expansion and this expanded variable on those objects instead of on the actual data assets that we're working with. But I'm just giving you a rough example here, not an actual implementation of an inventory system. Either way, this expanded event dispatcher that we have here is going to send through a reference to the item itself. So the item will be a data assets item object reference, and then whether or not it is new expanded state. So new expanded state, which will be a boolean. We're going to do that through a custom event here, which will be expand state or whatever. I don't know why I can't just call it expand. Oh, because I already have an event dispatcher called that. That makes sense. And that's just going to set, first and foremost, our expanded value to being the opposite of what it is now. So we get it. We set a not boolean, and then we set the value of that. And that's going to give in our new expanded. And the item is just going to be a reference to self. Now, back in our tree item, when we press that button we just added, this button over here, when we click that, and we make sure that we have that variable to it, this might have been added between cuts, so I'm making sure that we're highlighting it here. We make a variable for our data asset for the item, so that we always have something to keep track of there. And now we can always just call the expand state. So, in short, this widget sends a signal to the item that it represents, and then that item sends a signal back to the actual tree view to do something with it. Can you tell why I don't like this default tree view implementation yet? Because it is really convoluted. Anyway, now that we have that, we can assign, or well, rather we can first cast to the data asset item, and then we can assign on expanded, and then we can finally get our tree view here, and then we can expand set item expansion for this item with its new expansion. And then in the tree viewer, what I did here is I just added in a vertical box below all of this with a couple of text blocks, just as a bit of garbage data that we can expand and unexpand. So how do we actually do that? Because now we have something to drive the signal back and forth on whether we should be expanded or collapsed or whatever. Now we need to actually implement what that means. So if we go back into our interfaces on the tree item, we can set on item expansion changed, and there we can then implement whatever that means. In this case, that will be our vertical box. Make sure that it's set to being a variable in your designer, and we can just set the visibility here, and we can do that based on a select from bool. If it is true, it's going to be visible. If it is not true, we're going to set this to being collapsed. Collapse is a really useful visibility option for your widgets, because it will make them invisible and also make them not take up any more like space in your widget. So it actually like collapses them. For things like this tree viewer, obviously quite useful. So now that we have that, we can press on this and we can expand and unexpand our tree view stuff. And obviously you could set this stuff to actually like display like more item data, like having a description of your item or whatever. You can do whatever you want with this. That's how the default tree viewer works. If you want to use it for simple stuff, like just having a bit of extra data that you just collapse and uncollapse, I suppose it kind of works, but frankly, just implementing this as functionality of this item viewer and just making this part of a list works much better. If you really want to use it, there you go. That's how it works, but I don't think I can recommend in most cases to rely on the tree viewer like list view that Unreal gives you. It's probably better to just mess around a little bit and build your own. The list viewer, however, is fantastic. List and tile view, I have nothing against. Tree view is Satan's work. We've gotten to a point with UI now where we can pretty much do whatever we want with enough time, enough code, and enough troubleshooting. With all of the built-in visuals, that is. And we have kind of neglected a lot of the visual styling options in all of these things, just because those are super context and taste sensitive, so going very in depth on them probably isn't like that relevant. But I do want to do one thing here today, and I want to show you the fact that we can pretty much anywhere that you can put in an image in a UI element, you can also put in a material, meaning that you can write an entire shader to accomplish animated effects. And in a lot of cases, that might actually be preferable to using hacked together elements of UI. An example is, for instance, an HP bar. I have a couple of HP bar tutorials, but you might be tempted for an HP bar to just be a progress bar. And if you need like some animation in that HP bar to animate that progress bar, have different colors, have different progress bars on top of each other, at some point, you're actually adding more widget components, which means that it's going to be more expensive to do that than just write a shader to do the things for you. So let's take a look at this right here. I'm going to make a material here. So we can just right-click, make a material, if I can select it. And we'll call this something like UIM for UI material. Scrolling texture. And this works effectively the same as any other material in the engine. So if you're not super familiar with materials, I have an entire playlist course getting you started and working with materials. All that is in the context of materials for 3D objects. But if we go in here and set the material domain from surface to user interface, a lot of that stuff just disappears. And we get a screen position and a final color as output. We can also, of course, set this to being translucent. And then we'll also get a opacity or masked. And then we'll get the opacity mask pin. For now, we're going to keep this at opaque. And if we just do a texture sample here, for instance, put that into the final color and set the texture that we're going to be using to just any texture in our project, we can see the preview here is just a 2D square of our texture. Let's say that we want to add in a banner to this so that it moves. We need to give in our texture coordinates and then a speed of like 0.1. And now we've got a material that will take in this one texture and move it in the X direction slowly over a period of time. We can now use that UIM material here to fill in this UI element. And you can see it just animates. Of course, when we play the game itself as well, you can see it also animates. So that is one thing we can do. Now, we can make material instances of this material with different textures, but just like anything else, really, you can go into your event graph, set your image on event constructs. We'll keep this stuff around for now for the lists because I'm too lazy to get rid of it, to be honest with you. But if we just put in a sequence and then we set brush from material instead, we can just make a material and do stuff with that. So let's, for instance, create a dynamic material instance of our UI material for the scrolling texture. Then we promote that to a variable, so we'll call that material, and then set that to be the material that we use. Then we can change this material at a later date and it will dynamically update our brush here, because we don't need to manually then tell the brush to display something else, because the brush is just displaying whatever that material says it should display. So all we need to do is say that the material needs to do something else. So let's maybe make this a parameter instead, which has a default value of 0.1, but then we can convert this to parameter, call this speed. And then after we set this, we delay for, let's say, 2 seconds, just for demonstrational purposes, really. We get the reference to our material again, and we set scalar parameter value. Make sure that it has the proper name, so just go over and copy paste it. And then we suddenly set this to a value of 0.4. So it'll be scrolling 4 times as fast after 2 seconds. And we'll be able to see that indeed, after about 4 seconds, it will cut over a little bit because of how the panning works. It's just kind of a limitation of the panner. But you can see that we have a dynamically changing thing for this material. And we can obviously also then maybe change this to being a different texture. So let's convert this to a parameter as well. Call it texture or text2, because I'm too lazy to type out full words. And then we delay for another 2 seconds after this, and we set a texture parameter value, which will be, again, just be smart and copy this over. Don't be a hero. Don't manually type it, because you're going to make typos and you're going to get confused as to why things aren't working. And then we'll change that around to being this thing over here. So now what we'll see is we'll have a material. After about 2 seconds, it changes speed, and then after 2 more seconds, it changes the actual image. So you can do whatever you want, really, now, right? Because you can write a shader to do whatever you want. We can do some wacky stuff instead of doing all of this with the dynamic materials. We're gonna kind of keep that for what it is, but instead maybe what we do is we change this. Let's start from pretty much nothing. Let's take a linear gradient here, and if we put that into the U gradient, you can see that that's a 0 to 1. So put that into a if node. If a is less than, equal to, or greater than b, we'll give in a certain value. So let's make those different colors. We only actually need 2 colors. If a is greater than b, so if the linear gradient is greater than our value, we'll make it black, and otherwise we'll make it a random color that we set here, like green. And of course we can make this into a parameter as well, call that color. And then if we set this to 0.4, you can see that we effectively are making an HP bar that fills from left to right. Now, if we then, for instance, multiply that value by half of the V gradient, we also have an HP bar that has a little bit of shading to it. Maybe half of the V gradient plus a quarter, just so that it isn't as black. And now we have a little bit of shading to this. You can shade this however you like, obviously, but just to show you that we can now write shaders to make our widgets look however we want. And here we have our kind of weirdly badly shaded HP bar. And once again, translucently, opacity is entirely supported as well. So we can even desaturate so that this is a just black and white value, and then use that to also drive the opacity. So that way we don't have that blackness if we don't want that. With all that, the sky is the limit. Your creativity can go wild with writing shaders for whatever it is you are doing. So be creative, do your thing, and have some fun creating some super cool animated widget visual. And just to be super clear, I'm doing this on an image now, but you can do this on anything that takes in an image, right? So I have a button here. If I want the button to look different, what I can do is I can just set this image here to being our UI material. And the button will then also render as that UI material, at least the content of it. We also have a bit of an edge to this. That's the outline setting. We can just make the outline 0. width 0, and then we have our button rendering as our material. So this isn't limited to just images. Anything that takes in a styling information will work. And we still can very much then tint this as well, right? So ideally, maybe what you would do is make your shaders in a grayscale, and then you can apply a tint on top of those with this. Menu navigation, the bane of every developer's existence, right? So let's talk about that a little bit today. If you've just been making UI and you've been testing everything with your mouse and keyboard, you probably haven't even thought about this too much, but what happens if you only have a keyboard? Or for games, more importantly, what happens if you only have a controller? You don't have a good way to like cursor over a button and click it. So let's actually get rid of a bunch of the stuff that I've done here in previous videos, because it doesn't really matter anymore. I'm gonna get rid of the code for it as well. And I'm just gonna add in a bunch of buttons. So let's add in just a handful of buttons like this. So we just copy and paste a bunch of these things over, and we kind of just place these on your screen kind of willy-nilly in a bunch of different places so that we can navigate between them. Because Unreal does a pretty decent job navigating between widgets by default. So if we just place these kind of all over the screen like this, how are we going to navigate between this? Well, first we need to talk about the concept of having focus. So let's actually make a separate button widget, now that I think about it, to show you that concept. We make a widget here, user widget, and we'll call this focus button. And all that this is going to do is it's going to have a button inside of it. And then we'll go into the event graph and just kind of on-clicked make a event dispatcher that forwards this on-clicked, because that's what you do need to do if you make a custom button like this. So when we click this, we just forward that event dispatcher to whatever parent might be listening to it. Every widget in your hierarchy is going to have this is focusable, and that just tells Unreal whether or not this widget itself can have focus on it. There's a couple of different things that can give something focus when you change your input mode from game only to UI only, which we'll actually do here in the HUD when we add it on constructs. We can get the player controller and we can set UI mode only. So set input mode to UI only. That gives us in a widget that we want to set the focus to. From there, navigation is about shifting that focus from one widget to another widget. So this focus button, the reason that I made this is just for visual purposes mostly, because we have these functions on added to focus path and on focus lost or on removed from focus path. I like using on removed from focus path. So this is getting run whenever this gets added to the focus path, which means that whenever this widget or a widget that is a child of this widget gets focused on, this event will run, and whenever the focus gets set to something that doesn't include this widget at all anymore, this runs. So what we'll do is we'll get this button, make sure it's variable, it already is, good. And we'll just set the color to some value, like this when it is added to the focus path. And then we'll set it back to whatever it is by default, which we can get right here, which is just white, I believe. So we just set it back to white whenever we leave its focus for that button. This is mostly just for visuals, so that you can kind of keep track of it during this video. So let's actually replace all of these with our focus buttons. So let's make a bunch of these instead and place those all around so that we can do our stuff. Now, by default, I'm going to set the focus to this one. So we just, whenever we go to our input mode for UI, we set our focus to that focus button. And then when we play, you'll see that it doesn't actually do that yet. And that is because while the button inside of this will by default be set to being focusable, the widget itself has a default value of not being focusable. So we set that to being focusable, and then we could even say, hey, when we focus on this, we actually want to focus on the button inside of it. That way we can easily click on the button with like a confirm. Now, if you already have any of these buttons added, you might find that they still have is focusable set to being false. But now if I add a new one, it should have focusable set to true. So you just need to go in and set these to being focusable by default, and I'll add in this one somewhere down here. Now we will see that it will select that button as being the focus. And I can actually like navigate kind of nicely up and down here with my up and down keys, and I cannot navigate to the left or the right. You think, okay, now we're at this one, so I want to move to this one. I press the right button. This is kind of where it falls apart. If they are kind of in a direct line to each other, Unreal's automatic navigation works well in. But you can see that we're kind of like, this is kind of weird, right? Because now I'm stuck with these two and it's just a mess. So let's take a look at the navigation for everything. So if I just press any one of these buttons and I scroll down, we actually have a navigation menu here. And by default, all of these are set to escape, which just means that it's going to escape this widget and try to find the next widget just in screen space that is going to like navigate to. And again, for the most part, especially if you have things like lined up in a proper grid, it does a well enough job of that. But we can actually say we want this to work differently. So we can say that we want it to stop navigation. So even if we have something to like this side of it, naturally you want to be able to go back and forth. But if I then say, well, actually, no, when I go to the left here, I want that navigation to stop. That just kind of means that it's not going to navigate to anything. Now I can't go left from here anymore, but I can go right. So that's what stopping does. Next up is wrapping. And this wraps around the like parent object. So in this case, that would be something like in a canvas panel that doesn't work that well. But if we put this inside of, for instance, a like horizontal box. So let's wrap this with a horizontal box. And then we give it a couple more buttons. Wrap is a little weird because you might think, okay, I put this to the very right, and then if I press right, it's going to wrap around to this side again. Wrap is actually something that we will put on the horizontal box on top of here, right? So I put a couple of buttons here in a horizontal box to show you. If I set the left and the right for this to wrap, that will make the selection within this box wrapping around. So now you can see that it wraps around to the left and the right side because that is how this vertical or horizontal box, rather, in this case, is set up. Because it's at left and right to wrapping, and everything inside of here can just remain as its defaults. So that is what wrapping does for us. Now, next up, after wrapping, we have explicit. And this is where things become really quite interesting. Because what if we want the box here to wrap around, but when we actually get to this and we press on the right, we do want it to go to some specific other widget. In this case, that would be probably like this widget, right? Or maybe this widget. So we can set this up as something that uses explicit navigation. You might think, okay, so I can just select a button. Not yet, no. This is a little bit of a weird quirk with the Unreal navigation. You can only set things to be explicitly navigated to when they don't have their default name. So let's say this will be our test button. We give it a explicit name, and now we can choose it. So their default names don't show up in here. When you give something a specific name, you can explicitly refer to it. So now we will be able to escape this box, and it will explicitly set the focus to this element when we try to press right when we're on that button over there. So let's set that up to the right because I did it on next accidentally. So let's do explicit, and then I Control Z through this as well. So we'll just call this button, and to the right we'll go to button. So now we'll see that if we press right on this thing, it explicitly goes to that thing that we selected. It doesn't go back when we press left because we haven't explicitly set up that connection that way. So we have to like really navigate back to this button, and then we can get back there. But wrapping still works in the other direction here. And that gives us two more things to consider for these. And that is custom and custom boundary. For the most part, custom boundary, I honestly don't really care for it. This is a custom function that can determine what widget is navigated to only when a boundary is hit. So when I try to navigate and it doesn't find anything to escape to, it will run that. Custom will just always run a function. So we can make a specific function, and now we can just set up any code that we want here, and the return value will be the widget that we navigate to. So let's, for instance, say that we want to navigate to this, or actually which direction? Okay, to the right. So it will be this. So we can just use this to also kind of work as an explicit, hey, just navigate to this. But obviously we have all the possibilities in the world. We get this navigation, which tells us whether or not we just press left, right, up, down, next, previous, or if our navigation was invalid. As well as having access to all the variables on this entire widget that we can write any super in-depth, super complicated navigation logic for, saying that if you, for instance, have less than 50% HP and you press right on something that could either select a potion or select the attack option. For some weird reason, you design your UI to work like that, right? If you're less than 50% HP, you might navigate to the HP potion instead of navigating to the attack by default. But if you are over 50% HP, you probably don't need to heal, so you want that navigation to go to your attack button instead. You can write any amount of custom logic in here to navigate to whatever you want. What it takes in as a return value is just any widget object. And you can obviously have multiple return paths with all different values that get returned. And again, the custom with boundary kind of just does the same thing. You can select the same types of functions. This will just only run when it tries to escape to a boundary that it doesn't have anything to escape to. So that's the basic idea of widget navigation. Make sure that whatever you're trying to navigate to is focusable, and then you can use these different navigation methods to navigate between your widgets however you like. For the most part, using just this escape by default does a pretty good job, again, especially if you don't have a messy UI like this where everything is offset from each other. But if you do need to, you can explicitly go to something else as long as that something else has a unique name given to it. And if you really need to, you can set up some custom code. To round out everything we are talking about with UI animation, right? You're going to want to animate some UI at some point. So what you can do is come up here into Window and enable your animations, and you'll get this animations workspace, and you can just add an animation. Let's call this one button slide in. Now let's say that we want to animate these two buttons, both of these. So we select them, and then we can click this add button and add either of these buttons. So let's add button number 4 and button number 2. You can also add their canvas panel slot if you want to animate anything about that. This is all the information about the button itself. This is how it relates to the canvas panel. Once we have added the buttons, we can click this new plus icon to create a new track. So what do we want to animate about them? Do we want to animate whether or not they're focusable, their transform, so their location and their rotation and that kind of stuff, their padding, their color, their opacity, anything that we want. We also can still add in the canvas panel slot if we want to. For now, let's just animate the transform for both of these. It'll make a default keyframe here, and we're going to go about 1 second into the future, and there we can animate the translation, rotation, scale, and shear to whatever we want it to be. So for this, let's say that we want to animate, well, actually not the X, but maybe like the Y. We want to animate it to go off screen, right? And that creates a animation, just like that. And then for this other button, I think what we probably want to do is we want to animate that in the X. So we animate this to the side. And now we have an animation where two buttons go off screen. That's the most simple animation that we could possibly make. Obviously, you also can make this a little bit more fancy by like animating in a little bit of shear as they move. So you animate in like a little bit of this. So it kind of feels like there's some motion to it, right? And then for this, we can probably animate the scale a little bit down. So what we do instead is we just like squash this a little bit. So that way it kind of feels like there is a little bit more movement to it all. That's mostly like just animation stuff. It's fairly rough. Nothing like too technical about this. Now we have this animation as a asset, as a component, whatever you want to call it, on this widget. So we can play this, let's say, when we press this button. So let's actually add in some text to this button so that we can recognize it. This button. Oh, these are not just normal buttons. Well, that's okay. We'll just add in a new button. That's fine with me. A new button here that's going to have a bit of text in it. So let's put in the text. And when we press this button, we'll play this animation in the forward direction. So we have this button, we have on clicked, and then we can play animation. From there, we can choose a animation, but you see nothing pops up here. If we go into our variables, you can see we have a category called animations, where we just have automatically populated all the animations we made. So we can play this animation like this. We can play it at any start time. We can play it a number of times on a loop. We can play it either forward or in reverse or in ping pong, which is first forward and then back in reverse. We can play it at any speed that we want, and we can restore the state of the widgets or not once the animation is finished playing. So by default, it doesn't restore the state. So when we play the animation, it will keep these buttons off the screen. If I set this to restore state, it will play the animation and then everything will jump back to its original position. Now, depending on the version of Unreal that you're working with, binding to the end of an animation might be different. In the newer versions, you get a animation widget handle out of this, which is just a handle to reference back to an animation that is playing. In older versions, you get an object reference out of this, which has some event dispatchers on it, which you can assign to, which are like animation started, animation stopped, animation finished, some of those, right? In 5.6 and beyond, it seems like those have been upgraded to being events on the widget itself. So if I look for animation finished here, you see that it is an event on the thing itself. So anytime an animation finishes, this event will run with a object reference to what animation just finished. So we can check whether or not that animation is equal to a specific other animation. And if it is, we can do whatever. In this case, what I'm going to do is I'm going to just do a do once node in this case. And that's going to play the animation again, but this time it will play it in reverse after a delay. So we delay for, let's say, a second. Then we play the animation again. Everything is going to be the exact same, but we're just going to play it in reverse. And then when that finishes, it's going to trigger this again, but this do once node will have closed, so it won't play it again, right? So that way, whenever we click on this button, we also want to reset the do once node. So this is kind of making our own like ping pong with a delay in between. Just to show you that we can play forward and backward. We have this event dispatcher, or this event rather, that can trigger when an animation finishes playing and all that kind of stuff. So when we press this button, it should play the animation, then wait a second and play it in reverse, and then we can press the button again afterwards. Obviously, if we want the animation to not be able to be like interrupted by another button press, we can put in a gate, which will start as being opened, and we'll put in a sequence where we play animation first and then we close the gate. And once this is all finished, we will open the gate again. This is a little bit messy with, number one, all the splines going everywhere. Also, this doesn't technically wait for this portion of the animation to be finished now, so we would need to like look at this again, and I don't really feel like doing that, to be honest with you. So now we have this, which plays the animation, waits a second, and plays it in reverse. And we can do that over and over and over again. So as you can see, by the way, as we are in the process of playing it back, I can click the button again, and it just kind of like cuts to the start of the animation again. So the code can use a little bit of reworking here, but I can spam the button all I want in the first part of the animation, and it's not going to reset because of the gate and the do once that we set up. So that's the basic idea behind widget animations. Obviously, you can animate whatever you want, right? If we have, for instance, the material that we made in a previous video, we have this UI material that I made, right? This scrolling texture, which is no longer actually a scrolling texture, but rather a health bar kind of deal. We can add that as well, and we can animate the parameters on this too. So if we add a track, we can add a track for the material, and then the material itself will tell you all the parameters that it has exposed. So we can animate this material's color. So we can animate this from being green, which is the default, all the way up to, let's say, slightly less green and more blue. And then it will interpolate between those two colors. So if you have more complicated shaders which have multiple parameters, maybe a parameter for like how much this thing is filled up, which we could do, right? We made that at some point. Like this is not a parameter at the moment, but if we convert this to a parameter, we'll just call it param, that's fine for now. We'll see that I can now add that parameter as well, and I can animate it as easily as this. So with that, you should be able to make some cool animations for your widgets. And I think you also now know everything you need to know to get started making mostly whatever you want with widget blueprints. Obviously, there is a bunch of more detailed stuff in specifically like these appearance settings that we haven't really gone that deep into. And there's a couple of widgets like the optimization widget here that we haven't really gone into. The background blur is another one that we haven't gone into, but it's pretty self-explanatory. Some of the primitives, but I think you can figure those out for yourself for the most part because they're not that complicated. So hopefully you make some awesome UIs with all of this information, and maybe in the future I'll dive in deeper with some more advanced, like fully built out UIs as example using all of this stuff. And a very big thank you to all my Patreons. You can see them on screen right now. If you want to help support the channel or get any of the project files in any of my tutorials, there's a link down below to the Patreon page to support me, or alternatively as a YouTube member. And a huge thank you to my Cave Big Brain tier supporters, which care more for coding than impulse control: Earl, Monserville Erno, my Cave Students tier supporters, Oiku, and my Cave Digger tier supporters, Mauricio Farias.